Hi students, am I live? Am I audible? Let me know in the chat box, everybody, if you can hear me properly and see me properly. Today we are going to do a very important chapter, the number first organic chapter from your 12th class, haloalkanes and haloarenes. In this session, I am going to tell you how to approach the questions. We are going to use two kind of approaches in this session. But first, let me know if you can hear me properly. Beta? Yes. Hi, everybody. Yes, Jeevan? Okay. Okay, I am live. I am live. Hi, Kirtiga. Hi, Deepika. Hi, Guna. Hi. This is a very... Hi, Imran. Hi, Vasant. Chalo, everybody, this is a very, very important class. Remember this thing. We're going to do haloalkanes and haloarenes in one shot, right? I'm going to use two kind of approaches to approach this chapter, right? Like we are going to solve all the JEE PYQs, means whatever pattern of questions are asked, like JEE questions are never direct questions. Remember that thing, especially in organic chemistry. You need to know how to approach those questions, how to recognize the reagent and use it in the reaction. This is a very important thing. I know what you will do. You will go through your NCRT, do this, do that, and do so many reactions. But until and unless you solve the questions, you know how to approach this reagent. What will be the nucleophile? What will be the electrophile? Till you don't know that stuff, you will not be able to approach those questions. Remember this thing. Hi Hardik. Hi Gryffindor. Hi Manasa. Okay? So without doing any further ado, I'm going to start. And I will let you know what all we're going to do in this session. Number first, we're going to start with what are haloalkanes, what are haloarenes, what is their type of bonding, right? First of all, we're going to look at that. Then how to prepare them, right? What are the preparatory methods they are? What are the name reactions in them? Very important from J point of view. Okay? The third thing that we're going to do is their physical properties, the boiling point, melting point. How are they affected? If I attack one another group, if I attach the other group, if I attach minus I group, plus M group, what will be the effects on that, right? Very important questions again. And then we're going to see what all chemical reactions they show, and also along with each topic, we're going to solve so many previous year questions. This is going to be an extended session. Just remember that. Okay? Thank you, Daksha. Chalo, let us begin. Let us begin this series. Number first, these are haloalkanes. What is the number first thing that you should know? What is the number first thing that you should know? This is the structure of haloalkanes, bacha. Okay, everybody can see this structure. Can everybody see this? This is a RX compound. What is happening? For example, this is your normal alkane. One of the hydrogen of alkane is replaced by the halogen. That's why we called it haloalkanes. Correct? And what is the hybridization of this alkane carbon here? Bacha, the alkane carbon is this carbon, right? To this carbon, one of the hydrogen is replaced by the halogen atom. What are halogen atoms? Your group 17 atoms, fluorine, chlorine, bromine and iodine are your halogen atoms. One of the hydrogen is replaced by that, and this is here. Okay? What is the hybridization of this? The hybridization is sp3 hybridized carbon. Remember this thing. What is it? This is a sp3 hybridized carbon. Now I'm going to show you more examples. For example, if I talk about this kind of vinylic halide. This is called bacha allylic halide. This is what? This is allylic halide. Okay? Allylic halide, again bacha, in allylic halide, what is the hybridization of this carbon to which chlorine is attached? This is the carbon, right? This is actually the vinylic carbon. One more second. See, like this, and like this. Okay? This is the allylic halide. Here the hybridization of carbon is again sp3 hybridized. Remember this thing. This is sp3 hybridized carbon, allylic. Similarly, here benzylic carbon. What is the structure of benzylic? I will draw a benzene ring, right? And to the benzene ring, I've attached a methane group. To this methane group, a halogen atom is attached. When halogen atom is attached to the methane group attached to the benzene ring, such kind of halide is called benzylic halide. Correct? Benzylic halide is again, bacha, what kind of hybridization? This is again sp3 hybridized halide. Okay? What are the next kind of halides, bacha? The next kind is vinylic halide, where to the double bond itself the halogen atom is attached. Can you see? To the double bond, the carbon to which the double bond is attached, to the same carbon the halogen is attached, is called vinylic halide. These nomenclature are very important because I will show you how many questions are asked from here. Here, what is the hybridization of carbon in vinylic halide? It is sp2 hybridized. Remember this thing. Similarly, if I talk about this kind of halide, this is the benzene ring, and to the benzene ring directly your halogen atom is attached. Such kind of halide, bacha, is called what? Such kind of halide is called aryl halide. What it is called? It is called aryl halide. Here again, the hybridization of the carbon to which the halogen is attached is sp2 hybridized. All of these things should be clear to everybody. Yes, Kritika. Yes, that's correct thing. This is understood. Now I will show you what is the importance of whatever I taught you right now. Look at this question asked in JEE Mains 2024. Who can answer this question? Example of vinylic halide is. What I'm going to show you here, what I'm trying to show you is such questions are very, very common in your JEE exams. What are vinylic halides? What are benzylic halides? What are arylic halides? Correct? Yes, bacha, in offline centers, the books are available. Yes, you can go and join those centers. Yes, bacha, those books are available. Yes. First answer I've got by Kritika and then Supriya. All of them have answered 1. Vinylic halide. Vinylic halide. Then Manasa and also has answered option number 1. Option number 1. ठीक है. Ma'am, can I score 100%? Yes, bacha. If you follow my strategy, especially for organic chemistry, pakka se you can score. It is not at all difficult to score 100% in chemistry. ठीक है? Jeevan has answered 4. Gryffindor team has answered 1. Bacha, this is the allylic halide. This is not vinylic. This is allylic halide. Remember this thing. This is allylic. See, to the double bond. This is the double bond and the halogen atom is separated by a single bond. This is allylic halide. Similarly, this is the correct answer which is given by most of the students, right? So first is correct because the halogen atom is directly attached to the double bond. Can you see? The halogen atom is directly attached to that carbon to which the double bond is there. For example, this is the double bonded carbon and to this carbon only halogen atom is attached. This is called vinyl halide. What it is called? Vinyl halide. See, such an easy question in JEE Mains 2024 plus 4 marks on the easiest concept. Next, again we have a question from JEE Mains 2024. Can you look at this question, everybody? Everybody. Assertion. Some kind of halide is given to you and they have asked you, is this an example of allylic halide? Is this a true statement or a false statement? Let me know in the comment section. The next is again, reason is given to you. Allyl halides are the compounds in which the halogen atom is attached to sp2 hybridized carbon atom. Is this statement true or false? Who can answer this? Who can answer this question for me? Yes, again another question. Let me know. Statement, ma'am, first is true, first is false, or second is true, second is false. Okay, Tanishka. Hi, Tanishka. Welcome back to my session. Mahesh has answered A is true, R is false. This is very true. This is a allylic halide, right? This is the double bond here. And then there's a single bonded carbon. And to that carbon, the halogen is attached. This is very allylic halide. So this is a very true statement. And allylic halides, the halogen atom is attached to the sp3 hybridized carbon. Can everybody see the sp3 hybridized carbon, right? So this is again what, bacha? ठीक है? Yes, this is a false statement. False statement. Very, very good. Everybody understood this thing? Now let's move on to the nature of the halide bond, the CX bond. What do you think should be the nature of this bond? Nature means, is this a polar bond or is this a non-polar bond? So can you see the halogen atom, bacha? It is the group 17 atom, right? Like your fluorine, like your chlorine, like your bromine, like your iodine are all your halogen atoms. Do you know that they have so much of these are the highest electronegative elements in the entire periodic table, right? Fluorine is the most electronegative element in the entire periodic table, meaning what? That it attracts most of the electrons to itself, right? Because it is attracting most of the electrons to itself, bacha. Then what is happening? This is gaining a delta negative charge, and therefore the carbon gains a delta positive charge. Is this thing clear to everybody? Now can you see there's a delta positive and a delta negative created, hence a polarity is generated in the bond. That means this is a polar covalent bond. Again, this is a covalent because by sharing of electrons only it is made, right? By sharing of electrons, this is a polar bond due to the polarity introduced by the halogen, and it is a covalent bond due to the electronegative difference, as the halogen atoms are very, very electronegative elements. This thing is clear to everybody? So due to this polarity induced, many properties will change, like their melting point, boiling point, right? So many properties, we're going to see so much of change in them. Okay? Next is, because of the polarity introduced, what is the next thing that should come to your mind? Ma'am, then what will be the dipole moment? What is dipole moment once again? Dipole moment is charge into distance. This is the formula of dipole moment. Q is charge and D is distance. Okay? Q into D is the dipole moment. What is the order of various dipole moment that we see? This is the order. Can you see that CH3Cl has the highest dipole moment, then CH3F, then CH3Br, then CH3I. What is happening? This is how group 17 is. Fluorine, chlorine, bromine and iodine, right? Now, as I'm going down the group from chlorine, what is happening? As I'm going down the group from chlorine, the dipole moment is actually decreasing. But fluorine is an exception. Why? Because fluorine is a very, very small atom. So due to that small atom, what happens? The distance becomes less, right? The bond distance is so much less. And can you see it also depends on the distance dipole moment. So because fluorine is a very small atom, the distance becomes so much less. Hence its dipole moment is actually lesser than the chlorine. Okay? So this is the actual dipole moment order due to the shorter CF bond length. Remember this thing. Otherwise what happens? As I'm going down, as the electronegativity is decreasing, right? As I'm going down, what else is happening? Electronegativity is decreasing, right? Hence, their dipole moment also decreases, with one exception, that is fluorine, because fluorine is a very, very chotu small atom. Hence, what happens? What happens, bacha? Its dipole moment is lesser, because dipole moment depends on the distance as well. This thing is clear to everybody? ठीक है? Beta, every chapter is important. Every chapter is important. Otherwise, I'll make a video on it sometime later. But let's focus on this right now. This thing is clear to everybody. We have discussed the dipole moment. What is the other thing that you can know? Can you tell me about their bond energy? Can you? Okay, first of all, let's look at the reactivity order. Reactivity means what? Which will be most reactive. Most reactive means what? Whatever bond is the weakest bond, right? The weakest bond is the easiest to break. Hence, it will be most reactive. Here, can you see the Ri bond, ma'am? The Ri bond will be the longest. Why? Because iodine is a very, very big molecule. Hence, this bond is the longest. Hence, easier to break, hence it is most reactive. So can you see that Ri is more reactive than RBr, than RCl, than RF. So as the size is increasing, the bond length will increase, hence the bond strength, bond energy will decrease. Hence what is happening? Reactivity follows this strength. So I will also write the bond energy trend. In the same manner, what will be the bond energy trend? Will it not be completely opposite of this, right? Will it not be completely opposite of this? If this is the reactivity order, which means, ma'am, RF has the strongest bond. Therefore, it is not reacting that much, correct? Hence, the bond energy is RF has the strongest energy, then RCl, then RBr, and then Ri. Why is it happening? Why is it happening? Once again, because fluorine is a smaller molecule, hence it forms a smaller bond. Smaller bonds are strong bonds. Hence, this is the order followed. Clear? Clear to everybody? Let's move on to the next thing. Next thing is methods of preparation of haloalkane. So I have told you everything about the bond. What happens to the haloalkane's bond? Right? What happens to the haloalkane bond, haloarene bond? What does it look like? Where it is sp3 hybridized, where is it is sp2 hybridized, what is the dipole moment? All these things are very, very crucial, right? Now, before we delve into the methods of preparation, I have again a very important announcement to tell you guys. If you like how you study on YouTube with Vedantu, then you have a very good news for you that Vedantu is now offline in your cities, right? So if you belong to any of these cities in India, you can see the list over here. Then you can call on this toll-free number. Okay, you can either call on this number, or there's a description box in the link below. You can go and check out the offline centers if you're interested to learn offline, even for the crash course that you are taking this exam, which is just right next. If you're taking the NEET exam especially, okay? And if you are preparing for the advanced, then again you can just connect with us for advanced also. Okay, so this is about the Vedantu Learning Center, which is in your city. If you're in these cities, just look at this, pause the video, look at all the cities given over here. If you can go to these cities anyhow and join the offline centers, and please do if you are interested, if you are very, very serious about your JEE 2024 advanced or JEE 2025 exams in general. Okay? And you can go and check out the centers, attend a few classes, and if you do not like it, if you see your marks are still not improving, you're still not doing better at tests, then 100% fees refund is again guaranteed by Vedantu, because Vedantu believes in just one thing, to help the students. If it is not helping, the program is not helping, then there's no use to pay, right? Then you do not have to pay. You just need to go to the centers, just click on the description box below, join the click on the link. There is a link given. Yes, bacha, to VITE, there's so many exams. There are BITSAT exam. All these exams we actually teach in this offline centers. You get a different course, different sheet for everything. As these exams keep on approaching, we try to manipulate the teaching accordingly for you to ace in those exams, whatever exam you're targeting. Okay? Beta, this chapter has a very high weightage. Right now, we cannot just divide the weightage of organic chapter. It is in general or organic chapter, right? Okay? And this is again some of the, when the test series is starting, right? Some of the information. Again on your screen, you can go check it out. The link is in the description box below. To join the offline center, or you can just book an appointment. If you just want to go and look at it, what is actually happening, who is teaching, how they're teaching, you can just go there and check it out of curiosity as well. Okay, and also there's another good news. If you know any of these teachers, I'm sure you are familiar with Pulkit sir. I'm sure you all must know her sir, and also KR Abhishek sir. So they will be coming to your cities, right? If you belong to any of these cities, which is the Bhubaneswar, Janakpuri, Delhi, or in Pune or in Patna. So in all these places, these teachers will be coming to meet you, to counsel you, to tell you what you should do, what you should not do. If you want some counseling, if you want some guidance that this is not happening with me, what to do, how to approach. So all of these things with these three gurus of Vedantu, right? We also just go and just ask questions to them. Okay, we still do that. We teachers do that. So you students have a very, very good opportunity to go and meet them in person. They are doing this just for you people, right? So this is all the good news that I have to share and all the resources where you can get your more knowledge. Yes, bacha, this series plus the test series, if you join, it would be enough. It would be enough for your JEE, right? This plus the test series. I'm again telling you, the more you practice, more you will know. If you do not practice, then nobody can help you, bacha. You have to practice. You have to get into that thing to do tests, to perform tests, and to perform well in tests, right? Now, let us come back to the preparation of haloalkanes where we stopped. Number first preparation from the hydrocarbons. What did I take? From the alkanes we are preparing. I took an alkane. This is a very important and very repeated reactions, right? So what do you take? You take a alkane and in the presence of Cl2 and H nu, what happens? This thing keeps on adding just like this. This is again a free radical mechanism reaction. Free radical mechanism. Okay? Through free radical, this reaction happens, and I've already taught you how this mechanism happens in the hydrocarbons chapter. Everything in chemistry is connected. I cannot teach you everything in every session, right? So go and see the hydrocarbon session. I taught you how free radical mechanism happens in this. Okay? You take a CH4 and you take chlorine or bromine or iodine, whatever you wish. Okay? Mostly this reaction happens with chlorine and bromine. That is it. Chlorine and bromine, this reaction will happen in the presence of light. What will happen? One by one, in each step, you will, one chlorine will get on, keep on adding. Okay, what is happening in this case? Bacha, you are getting a mixture of products. Can you see? You're also getting a methyl chloride. You're also getting CH2Cl2. You're also getting CHCl3 with this chloroform. And you're also getting carbon tetrachloride. So you're getting a mixture of products. You're not getting one kind of haloalkane. So this is not recommended, right? So this reaction, bacha, this reaction is not suitable, right? Not suitable to prepare one kind of alkyl halide. Why? Because a mixture of products is formed over here. Can everybody see? So we do not want mixture of products. We just want one kind of alkyl halide. So this is not a suitable kind of reaction to happen. But this happens. This is a very important reaction. So many questions are asked every year based on this reaction. So you must know. Okay? Next is, now we saw how to prepare alkyl halide from alkane. I told you. Now we're going to see how to prepare alkyl halide from alcohols. Very, very important. So how do alcohols look like? They are ROH. To the hydrocarbon OH group is attached. So what is happening? We are replacing this OH group. What you are doing? You are substituting this OH group with the halide group. What group? With the halide group. So this is the ROH, right? And you are going to react it with something, and the product that you are getting is a RX product. Remember this. So what is happening? Substitution is happening. One is getting eliminated, the OH is eliminated, and the X is added in its position. So this kind, all of these reactions, bacha, are your substitution reaction. Remember this thing. Substitution reaction. Okay? These are all substitution reactions. Ma'am, is fluorine and iodine taking? No, bacha, fluorine and iodine do not react in the last reaction. And why they do not react, I explained in the last lecture I took with the hydrocarbons, right? I'm not going to repeat it again due to time constraint. Otherwise, I'll keep on repeating the same concepts, right? So this is, okay, what is happening on a broader level? Just see this. Now, just look at the reactants. For example, with ROH, if you try to react it with HCl and ZnCl2, then what do you get? You again get the RCl product. Okay? Now, there's one thing to remember. one thing to remember is bacha what? That with primary, I'm writing it here. With primary and secondary alcohols, you need the ZnCl2, right? You need the ZnCl2, but with the tertiary alcohol, you do not need the ZnCl2. Again, I'm writing over here, with the tertiary alcohol, no catalyst required. No catalyst required. Write these things in your notebook. Okay? With primary and secondary alcohols, you require the ZnCl2 catalyst to make the alkyl halide. But with tertiary, no catalyst is required. Number first reaction. Okay? And I'm going to tell you most important points about this reaction. For example, if I react ROH, which is the alcohol with the SOCl2. The name of this is thionyl chloride. If I react it with thionyl chloride, all the products that I'm getting, RCl, SO2 and HCl, both of the side products, right? These are the side products. Both of the side products are bacha gaseous. Because both of the side products are gaseous, then they will evaporate away in the reaction itself, hai na? And what you will be left behind in the beaker? Just pure RCl, right? And hence this is, with the SOCl2 with the thionyl chloride, this is the most preferred method of preparation of alkyl halide. Why? Because the side products are gaseous. So this is, I'm again writing is, this is the preferred method. Preferred method. Okay, everybody understood this? This is the preferred method to prepare the alkyl halide. Okay? The other methods are, you can take NaBr and H2SO4, or even you can take NaI and H2SO4, and no, you cannot take NaI, you can take NaCl. Okay? NaBr, NaCl, again you cannot take NaI. Remember this thing. Okay? I'm again writing it here. Okay, I'm writing it here. All the exceptions I'm writing. NaI, there is no reaction with NaI. Why? Because with I, what gets? It gets actually oxidized in the reaction itself, and hence the reaction doesn't continue. So you just need to know with NaI there is no reaction. Okay? And then again you can use PCl5. With PCl5, what is the product? RCl is the product. With red phosphorus and X2, RX is the product once again. With PX3, again what you will get? The ROH will convert into RX. What is happening? You're just replacing the hydroxide with the halide ion. So all these reactions, whichever are written here, very, very important. Okay? Very, very important. Bacha, the notes are on the Telegram channel. The notes will be posted in the Telegram channel. Okay? Yes, Lucas, reagent is HCl plus ZnCl2. You are absolutely right. Okay? You understood that part? You understood that part? Now, with the alcohols, I told you, substitution reaction happens, right? With all those reagents which were there, please go through those reagents, very easy reagents. Next is, with alkenes, how can you prepare, once again, your alkyl halide? So, with the alcohol, substitution was happening. One thing was eliminated and it was getting replaced by the other thing. In alkenes, what happens, bacha? Addition reaction happens. What happens? Addition reaction happens. Remember this. What kind of reaction? Addition. This is a double bond. To the double bond, you're trying to react HX. Okay, when I'm trying to react HX with the double bond, what will happen? Here it is the H plus ion. Here is the X minus ion, right? It can break down like that, H plus and X minus, because this is an acid. Now what happens? This double bond is what? Electron rich. Remember this thing. This is electron rich, right? Electron rich means what? This will attack the H plus very firstly. Hai na? If it attacks the H plus, what will happen? What will happen? Again, a carbocation will be formed. For example, attack the H plus. The H got attached over here. Therefore, the carbocation will come over here, and this is the thing. Now, what will happen? The X minus now attacks this carbocation, and the final product that you get is actually like this product, C, 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 and here was the H, and here will come the X part. Okay, everybody understood? This is how this reaction happened. Once again, look at this reaction. Okay, everybody understood this? Okay. Also, let us go back once again. Let us go back. Reaction which I told you, right? In this only and only, I'm writing over here, the ROH plus whatever reagent which gives Rx, right? This is a kind of, what did I tell you? This is a kind of what? Substitution reaction, right? This is a kind of substitution reaction. What is happening? The OH is leaving. You are breaking the carbon and oxygen bond. Can everybody see? You are breaking the carbon and oxygen bond. Okay? So this substitution is only possible to prepare alkyl halide. What halides? Alkyl halides. Remember this thing. Only alkyl halides are prepared by this method. Aryl halides are not prepared. For example, let's look at aryl halide. Okay? Aryl halides are not prepared by this method. Okay? By this method. For example, this is the this 1, 2, 3 and here the OH is there. So this is the phenol compound, right? It is very hard to break this phenols, carbon OH bond. Why? Because this oxygen's lone pair go into resonance with this bond. What is happening? The oxygen lone pair goes into resonance with this bond. Hence what happens, bacha? This single bond, this carbon oxygen single bond gains a partial double bond character. Can everybody see? Gets a partial double bond character due to the resonating structures. Hence, this CO bond is very, very difficult to break. So, this doesn't break. So, substitution reactions do not happen with aryl halides. This, you cannot prepare aryl halides in this case. Why? Because due to resonance, this structure happens. Everybody is understanding this? Yes, delocalization of pi electrons happen. Okay? Only alkyl halides can be prepared. Aryl halides cannot be prepared. Very good. Okay. Now we were talking about this preparation. This preparation is okay with everybody. With HX, this kind of products is formed. Again, a very, what kind of product is formed? Carbocationic products are formed. Let us look at this reaction. Again, bacha, in this, for example, if I have an unsymmetrical alkene, the same reaction we're talking about. I took an unsymmetrical alkene, which is 1 propene, and I'm trying to react it with HI. What can happen? What can happen? There are two possibilities now. There are two possibilities. Number one possibility is either the hydrogen can get attached over here and therefore the I gets attached over here. This is one possibility, right? The other possibility is what? The other possibility is that the I gets attached over here and the H gets attached over here. These are the two possibilities, right? Okay? So what will be the major product in this case? How do we decide? We decide through the Markovnikov rule. What rule? Markovnikov rule. Right? What does it say? It says that the halide ion, the I is the halide ion, right? The halide ion attaches to that carbon where there are minimum number of hydrogens. Where are the minimum number of hydrogens? In this. This has the minimum number of hydrogens, this carbon. Hence, to this carbon, to this carbon when halide is attached, this will be the major product, the other will be the minor product. Okay? Understand this thing. Why this happens? Because this reaction takes place via carbocation mechanism, and we know that secondary what will happen? This will be the secondary carbocation. Here it is the primary carbocation. Also, the secondary carbocation is more stable than primary carbocation. Hence, this will be the major product. Ma'am, what are you saying? Can you explain it to me? Yes, I can explain it to you. Now, look at here. What am I saying? I'm saying CH3, CH, double bond CH2. This was the alkene and you were trying to react it with HI. Right? This was the reaction. Now with this can convert into H plus and this can convert into H minus. Right? What did I say? The double bond is electron rich. Hence it will attack. It will attack the H plus over here. Right? Now what will be the next step? The next step will be CH3, CH. Here it will be CH2. Right? Now what can happen? To one carbon the hydrogen will attach and to the other carbon the positive charge will come. So the hydrogen will attach on this carbon so that the positive charge can come on the more stable secondary carbocation. Isn't this a secondary? So this is more stable carbocation. Hence the I minus now attack this positive charge. Hence the final major product form will be CH3, CHI, and here it is CH3. So this is the major product. Which is, it will be from 80-90%. The other will be just 10% of the product. Is this thing clear to everybody? Is this thing clear? Next, preparation of haloalkanes from alkenes. Now we're talking about once again. Number first reaction with alkenes was HX, which was a carbocation mechanism. Addition happened through the Markovnikov rule. Number second with alkene, I'm taking another reagent which is the NBS. Very favorite reagent for your examiner. NBS is called N-bromosuccinamide. What is the shape of N-bromosuccinamide? This is the structure of N-bromosuccinamide. Remember this structure. Okay, very, very important structure once again. So what happens with NBS reagent? Remember, here again, NBS has what? Bromine in it. Okay, NBS has bromine in it. And in the final product, when you took an alkene and you reacted with NBS, in the final product, bromine will be added to the allylic position. Allylic position. Remember this thing. Always the bromine will be added to the allylic position. Can you see which is the allylic position to the alkene? This is the carbon with the double bond, and the carbon right next to that, right next to the sp2 hybridized carbon. Here the bromine will attach. This is your allylic position. Okay? So here always the reaction will happen at the allylic position. Okay? Everybody understood? Everybody understood? Okay? And there is another example, bacha, where only allylic addition happens. What is that other example? For example, let me tell you. For example, you took again CH3, CH double bond CH2, and you try to react again with HBr. Okay? Again with HBr. But right now, in this case, what did you did? You took a peroxide. What did you take? You took a peroxide. Okay? In presence of peroxide, bacha, the major product will get reversed, because in peroxide the mechanism that is followed is again free radical mechanism. Number one thing that you should know, in every peroxide, no matter where in organic chemistry you're studying about the peroxide, all the peroxide reactions, bacha, are your free radical mechanisms. What happens? This is your alkene, this is HBr. Right now, previously I told you that Br will get attached through the Markovnikov rule. But in presence of peroxide, what happens? The major product is the anti-Markovnikov product. So the major product is CH3, CH2, and here is CH2Br. So this is the anti-Markovnikov product. Remember this thing. With the HBr and peroxide, anti-Markovnikov product is the major product, and absence of peroxide, Markovnikov product through carbocation mechanism was the major product. Here the mechanism is free radical. Remember this thing. Okay, this is the second case we read with alkene. The third case was N-bromosuccinamide. The addition of your halogen will happen at the allylic position. Correct? 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 Next is from alkenes. This is a very, very important reaction. I will tell you the variations of this which are asked in your JEE exam. This is again an alkene. Now I'm reacting this alkene with Br2, right? With Br2 in the presence of the solvent CCl4. Please concentrate on the solvent. What kind of solvent is CCl4? This is a non-polar aprotic solvent. Aprotic solvent. What does it mean? Non-polar means what? It has zero polarity. Why does it have zero polarity? For example, this is C, Cl, Cl will be attached here, here, here. All the Cls are in tetrahedral position. All the chlorines will attract the electrons towards its, because chlorine is more electronegative, all the electrons will be attracted towards itself in Similar manner, hence this is a non-polar molecule. Aprotic means what? Which do not have the capability to give out protons. It cannot give out H plus ion. Hence it is a aprotic solvent. So what you have to remember whenever, do not even remember aprotic. If you can only remember non-polar, that is enough. Whenever non-polar solvents are given and your Br2 or even your Cl2 is given, then what is the reaction? The reaction is to both the bromine, to both the carbons, where the double bond is there, to both those carbons, 2Br will go and attach. So you will get a vicinal dihalide. You will get what kind of halide? Vicinal dihalide. What is the reaction mechanism? Very important. Please write it down because so many questions are asked from the reaction mechanism. How? We will get to know in just some time. Okay, for example, this is the alkene. C double bond C. Here is the H. Here is the H. Here is the H. And here is the H. Right? And you are trying to react it with Br2, which means it has two bromine molecules. One Br here, the other Br here. Okay, this is the structure. Now, bacha, what happens? One of the bromine will get a delta negative positive charge. The other bromine will get a delta negative charge. Remember this thing. One gets a delta positive, one gets a delta negative charge. Now, again, this is electron rich alkene. Hence, the electrons of alkene will attack the positive side of the bromine. Okay? When it attacks the positive side of bromine, what it will form? It will form a carbon just like this. This was the carbon. Okay? And here SA, and to this there will be a formation of this kind of cyclic structure. Remember this thing. Can everybody see a bromine plus cyclic structure is formed on the double bond? Okay? Now what is the next step? The next step is that this actually breaks off. This actually breaks off this bond. Any one of the bond. You can either break this bond or that bond. It is dependent on you. The next step would be, after this bond breaks, what will happen? This will be C. C, for example, the Br gets attached over here. So this carbon will now get the positive charge. Correct? Now this delta negative bromide now attacks this positive charge. Hence the final product is your vicinal dibromide product. One Br got attached in the below, the other Br got attached the above. Can everybody see this? Can everybody look at this reaction? This mechanism is very, very important because it has been asked so many times in your JEE exams. I will tell you the importance of this mechanism. Did everyone understand, or do you want me to draw it once again? Do you understand this? Beta Anurag, I just told you Markovnikov happens. So the rules you have to remember: with which reagent ma'am Markovnikov happen, with which reagent ma'am anti-Markovnikov happens. Okay? You have to remember that. Most definitely with peroxides, I don't know why did this light is switch on. Okay. Okay? Understood everybody? Understood everybody? So, bacha, always remember with peroxides, no matter what reagent, but if peroxide is written after that, it will always be the anti-Markovnikov rule. Okay? Number one thing. And where the Markovnikov additions happen, mostly in the cases where carbocation is forming. Okay? Agar if you know the reaction mechanism and the carbocation is forming, then pakka it will go through the Markovnikov addition. Okay? This is the main funda that you have to keep it in your mind. Everybody understood this reaction mechanism? Okay? Now again, what is the other thing I told you to focus on? The solvent with Br2 here. Can you see the product here that we're getting is actually the anti-product. Anti-product means what? That one Br attaches from the below, the other Br comes from the top. Okay? It is always the anti-addition. Okay? It is always the anti-addition product. Write down these points, very, very important points. Okay? The other thing what I'm trying to do, I'm trying to show you another thing. For example, I took the same alkene. And now I'm trying to react it with again Br2. But right now, the last time the solvent was a non-polar solvent, CCl4. Now I'm taking a polar solvent like water. So now what will be the reaction? Now what will be the reaction again, bacha? Now here the product form will be On one carbon, the bromine will attach. On the other carbon, the OH will attach. Remember this thing. Whenever the solvent is a polar solvent, है ना? Polar solvent, then some part of that solvent will be added to the next thing. ठीक है? अब for example, if it is an unsymmetrical alkene, for example, it is CH3, CH, double bond CH2. ठीक है? Now, ma'am, I'm adding once again Br2 in the presence of H2O. What will be the reaction? So here again, bacha, here again, what will happen? CH3, CH. So to the, here again, Markovnikov rule will be followed, and to the Markovnikov product, here the OH will be attached, and here, bacha, CH3, here the, sorry, CH2, here the Br will be attached. Again, a Markovnikov product is formed, where the OH is attached to the central carbon. Is everybody understanding this? The OH is attached to the central carbon. ठीक है? ठीक है? Everybody understood? Everybody understood? Chalo. ठीक है, everybody. Now let us do the question. This question is the JEE Mains 2023 question. Can everybody see on the screen? Now we'll let you know the importance of the mechanism that we just studied. Major product P formed in the following reaction. This is just the last year JEE Mains question. Can you attempt this question? Who can answer this question for me? Again, what it is given here? Here, there's an alkene given to you, right? Can everybody see? And you're trying to react it with Br2 and sodium bicarbonate. Here again, the solvent is different. Can everybody see the solvent? Can everybody see the solvent? Yes, who can answer this? Who can answer this? Option 2, somebody answered. Option 2. Okay, I will give you 30 more seconds to answer this. 30 more seconds to answer this. Thirty more seconds. I'm looking at the chat box. Please let me know the answer. Please let me know the answer. Yes, bacha. Let me know the answer. 4 I got by Mahesh. 4th answer. Hi Manu. Hi Sujal. ठीक है. 4th answer Tanishka. 4th answer Sujal. 3rd answer Roshni. 4th. ठीक है. Now I will let you know how to perform this reaction. Now what is the first thing that you can see? Here the Br2 is there, right? So I am again drawing this product like this, OH. Here is double bond O. Here is the alkene. Okay, this is the product reactant given to you, and you're trying to react it with again Br2, which means one of the Br, ma'am, will get the delta positive charge, the other Br will get a delta negative charge, isn't it? This is the condition. Now, ma'am, what will happen? This double bond will now attack the positive thing. Also, bacha, whenever I'm drawing these mechanisms, please understand, please just focus ki I always do what? Ki I always make the arrows from the electron rich thing to the electron deficient thing. Always do that. Always the arrow will go, always the electron rich thing will attack the positive thing. Always remember this, no matter what reaction you're doing, the arrow will be followed this from negative to positive. This is the electron rich reason, and this will attack the positive bromine. Now what will happen after it attacked it? The answer will be, the next thing that will be formed will be something like this. OH will be here, double bond will be here. Okay, this is a very important thing that I'm going to explain to you. Now, bacha, what was happening? Here, ma'am, Br positive happened and a circular thing was formed, right? This is the thing we studied in the reaction mechanism with Br2. Now, can you see? Now, can you see? This is a positive charge here. है ना, there's a positive charge here. And this OH is what? This OH, can you see? This OH bacha has a negative on oxygen, and है ना, this OH is what? The oxygen has a negative charge on it, and this H plus can go away. This can easily go away because this is an acidic group. This is a COOH, acidic group. Easily can give away the hydrogen, right? So here the negative charge is over here. Now what should be the next step? Bacha, what I'm trying to teach you through these things is कि very basic chemistry is used in solving majority of the reactions in your JEE exam. JEE exam is not direct like NEET. Like you will be given one reaction. What majority of the teachers do, they just teach you those basic reactions, right? And you will be able to know the answer to them because you have looked at them so many times in your NCERT, in your various other practice books that you see. But how to approach question in actual exam, this is just last year question, nobody teaches you. These things are very important to learn, which I'm telling you now. Please focus on them. Okay? Now bacha, what will happen? This positive and this negative is there. So can one thing happen? Ki if one of the bond breaks, for example, if this bond breaks, then the positive charge will come over here, right? The positive charge will come over here, right? If this bond breaks, this positive charge comes over here, and this negative can therefore attack over here, right? Can everybody see this? This positive can attack over here, है ना? ठीक है? This was the thing. This was the thing. Everybody is understanding. Now what can happen? This will form a cyclic structure now. Why? Because always remember, if in any reaction there is a possibility of formation of either 5-membered or 6-membered rings, then always and always form those rings. Can you see that there is a possibility of 1, 2, 3, 4, 5-membered ring formation? Hai So a 5-membered ring will be formed like this. 1, 2, 3, 4. Here is the oxygen, right? And here, just like this, a 5-membered ring is formed. Let me draw it in a better way. The 5-membered ring will look something like this. This is how the 5-membered ring will look. Okay? And to this carbon, the bromine is attached, right? And to this carbon, double bond O is attached. So can you see a 5-membered ring product is formed? So the answer is actually the second product. Whoever gave me this, one of the students actually gave me the second answer. So that is actually the correct answer. Everybody understood? Did you understand this mechanism? Can you now know, ki ma'am, how actually the reactions happen? You have to know. There are some of the important mechanisms even given in your NCERT. Only those mechanisms are important. I'm again telling you, only those mechanisms given in your NCERT are important, but based on those mechanisms, many variety of questions can be asked. This is one such variety. That's why I've included. Because still you do not understand how to approach this. Majority of the students will do this question wrong. Hai na? So you need to know the basics of chemistry. Oh, one gets a ma'am positive charge, the other has a negative charge, and there is a possibility of formation of 5-membered ring. I will definitely form the 5-membered ring. But if 4-membered ring was forming, you will not form, because 4-membered rings are not stable and hence will not be formed. 3-membered ring not be formed. Only 5 or 6-membered rings, if they are possible, then only do these kind of intramolecular reaction. This is a kind of intramolecular, right? Only in that cases intramolecular ring formations will take place. Chalo, next question. So this is the answer to that question. Okay? Now the next way we discussed right now, 2 ways. This is the third way. By halide exchange you can make another haloalkane. Hai na? By haloalkane, the halide exchange means what? Very important name reactions these are. So what are we doing? We're taking an alkyl halide already alkyl halide, and trying to react it with sodium NaI in the presence of acetone, and we are heating it. Okay? And what all alkyl halides can you take? You can either take a chloride or bromide. That is it. You cannot take fluoride here. Only chlorides and bromides react with NaI in presence of acetone, and a halogen exchange happens, which means this X comes over here and this I goes over here. So this is a very good preparation, this method of preparation to form alkyl iodides. This has a specific name reaction to it, which is called the Finkelstein reaction, And here what happens, bacha, this NaX formed, which can be NaCl or NaBr. Both of these things, bacha, are insoluble insoluble in what solvent you have taken? So insoluble in acetone. So due to that, what happens? Because this will now become the precipitate, because this is insoluble. Now because this is precipitating in the reaction, hence not taking part in the reaction. So due to that, what happens? The equilibrium of the reaction shifts in the forward direction due to this precipitation. Very important point. The equilibrium shifts in the forward direction because this precipitates. Okay, number first halogen exchange. Number second halogen exchange is called Schwarz reaction, where you do what? You again take a alkyl halide. It can be any alkyl halide and you react it with either AgF or any metal fluorides. Could be silver fluoride, could be mercury fluoride, could be cobalt fluoride, or could be antimony Sb fluoride. Okay, you can react with any of these things. And what is the product you're getting? You're getting alkyl fluorides is the product. This is called Schwarz reaction. Very important kind of reaction. And again, AgBr is formed as a side product. Okay, this thing you understood? Okay, everybody understood this thing? Shall we move on to the next thing? ठीक है, carboxylic acid release H plus and is becoming negative charge and it migrates to the cation. Got it, ma'am? ठीक है, very good. Now let us look this JEE Mains 2023 question. Who can answer this question for me? Look at this question. For the reaction, one of the question is given. Can you just look at the reaction first of all? Just look at this reaction given. We are reacting one alkyl bromide with the iodine ion, है ना? Iodide ion in presence of acetone, and you're getting an alkyl iodide as the major product. ठीक है? Can you let me know what is the name of this reaction? I just taught you. What is this reaction called? It has a specific name. What is this reaction called? We just learnt about this reaction. Who can tell me? Who can tell me the name of this reaction? Who can tell me the name of this reaction? Yes, bacha. Who can tell me the name of this reaction? I'm looking at the chat box. Please tell me. Please, please, please. Finkelstein. Very good, Roshni. This is the Finkelstein reaction, right? Iodide is formed. Why are you not able to answer? This is the Finkelstein iodine exchange, halogen exchange reaction. The bromine is getting exchanged with iodine. Finkelstein. Yes, now everybody is getting the answer. Yes, Finkelstein reaction. And this is again a 2023 question you have to answer. The correct statement is, bacha, this session is very crucial for your preparation of JEE 2024. Please take it seriously. I'm going to teach you so many different concepts which nobody has ever taught you. This is my guarantee. You'll only learn it here because I am ready to put in efforts for you guys. I do not do just those reactions which just everybody know, which is there in the NCERT, which is there in the practice books, right? You already know those reactions. What is there to learn then? These things are there to learn, right? Now, what do you think is the answer to this question? What do you think is the correct statement among these four? The transition state formed in the above reaction is less polar than the localized anion. Okay. Again, I'm going to tell you one more thing. This reaction, bacha, happens through SN2 mechanism. If you have a basic idea of SN2, otherwise I'm going to teach you in this lecture. Okay? Because this was a kind of Finkelstein, so I added it here. Otherwise, when we will learn SN2, then I'm going to teach you what happens in SN2, right? Okay? For now, somebody has answered 1. Is less polar than the localized anion. The reaction can occur in acetic acid also. The solvent used in the reaction solvates the ion formed in the Br minus can act as a competing nucleophile. So first answer I've got is by Sumanti Satish, and that person has told you, ma'am, the answer is first, is less polar, is correct, which is very, very good. You're right. You're right, Sumanti. This is the correct answer for that. Okay, and now when we'll read about the SN2, we'll again come back to this question. Remember this thing. Okay, right now I'm just leaving it here. Okay, because I've not read SN2 yet, so you cannot understand this. But just look at the level of the question so that you're prepared for 2024. Okay, now next. Again, who can answer this JEE Mains 2023 question? Devil Boy, Roshni has all answered to me 1. Okay, JEE Mains 2023 question. 2 statements are given to you, assertion and reason. Hydrolysis of an alkyl chloride is a slow reaction but in the presence of NaI, the rate of hydrolysis increases. This is again a Finkelstein-based assertion reason. Again, Finkelstein. Because what it is saying we have taken an alkyl chloride, we have taken a RCl. In the presence of NaI, you're trying to react. Okay, the rate of hydrolysis increases. Is this a correct statement? Is this a correct statement? Yes, bacha, this is a very, very correct statement. That is why Finkelstein reaction is very popular, because the rate of hydrolysis increases. Okay? True statement next is I minus is a good nucleophile as well as a good leaving group. Is this a true statement? This is again a true statement. What makes a good nucleophile? I minus. Nucleophile means what? Which has a negative charge in it, right? Because it has a negative charge in it, it is definitely a nucleophile. Nucleophile means what? Which are nucleus loving, positive loving. If I have a negative charge on me, I will be attracted to a positive charge. So I am a nucleophile and I am a very good leaving group. Yes, bacha. I minus is the best leaving group. Remember this thing. This is what? This is the best leaving group. One of the things that you should know, leaving means it is very easy to remove it. Why? Because it is a very big molecule. Hence, the bonds will be long. Hence, it will be easier to break. It is very good leaving group. So, both of these statements are true. You will learn one new thing which with every PYQ we're going to do. Everybody understood this thing? Everybody understood this thing? Yes, and R is a correct explanation of A also. This is also true. Both are correct and R is the correct explanation also. Correct. Next is again another preparation of alkane we're doing. The next is Borodine-Hunziker reaction. Again a name reaction. Hunziker is what? We take a silver acid. What I'm taking? I'm taking a silver acid of the haloalkane. This is silver acid and I'm reacting it with Br2 and CCl4. What will be the reaction? In this bacha, what happens? One less carbon of alkyl halide is formed. Here the COO2 will go away. The CO2 will go away and the Br will get attached over here. This is the final product. The CO2 goes away and the Br gets attached because we've taken Br2 here in the presence of CCl4, which is again a non-polar solvent, and hence this is the product. Bromomethane is a name reaction once again. Name reaction, Borodine-Hunziker reaction. Correct? Understood? Next is preparation of haloarenes. We have done the preparation of haloalkanes, done and dusted. Okay? Now we are here with haloarenes, okay, which is the sp2 hybridized carbon. So first method is from hydrocarbons by electrophilic substitution. What is meant by electrophilic? So can you see this is the benzene ring here, right? The benzene ring has so many pi bonds. Can you see there are 3 pi bonds which are constantly resonating. Hence, all these pi bonds make the benzene structure what? Makes the benzene structure electron rich. Hence, can you see this is an electron rich structure. Hence, what kind of reactions it will show? It will show electrophilic addition reaction, which means whichever are electrophilic substitution reaction. Okay, what are electrophiles, bacha? Whichever has a positive charge on it are electrophiles. So the positive charge will be attracted to this negative, because this is a very charged high benzene, right? So positive charge will be attracted to it, right? Now, number first, what kind of reactions these benzenes show? These show electrophilic substitution reactions. Okay, substitution means what? For example, you took this kind of toluene. If with toluene you're trying to react with X2 and Fe in dark. Okay, you have taken a catalyst as well. Now what will be the reaction? You will get a orthohalotoluene and a para-halotoluene. Why? Because CH3, here CH3 is a ortho and para directing group. Hence the incoming halogen will be added to either the ortho position or the para position. Okay? Now this halide will be what? Ma'am, how is this electrophilic substitution? Because here somewhere the H was present, right? So the H is getting replaced by the halogen atom. Can everybody see that? The H is getting replaced by the halogen atom. Here again what happens? This X2, this is the X2, one will get the delta positive charge, one will get the delta negative charge, right? And the delta positive charge will be attracted by the benzene ring. So what kind of reaction we are studying? Electrophilic substitution reaction, because the hydrogen is replaced by the halogen atom. Correct. Next is again preparation of haloarenes. Very, very important, from the amines by Sand-Meyer reaction. So this is the amine molecule. This is the aniline molecule, right? So we are taking what, bacha? We are taking primary aromatic. Remember this thing, we're taking primary aromatic amines and we're reacting it with sodium nitrite and HX at very cold conditions, 0 degree to 5 degrees Celsius. And what is the product we get? We get a very, very important diazonium salt, benzene diazonium salt. You will read a lot about it in the amines chapter. What happens? This NH2 gets converted into N2 plus and X minus. Okay, now this N2 plus and X minus is a very important class of compound, because now this N2 plus and X minus can be converted into anything. Anything. You can attach chlorine, bromine, fluorine, any kind of atom to it. Even your nitrate, even your SO3H, whatever you want to attach, you can attach to this diazonium salt. So now that we have prepared the diazonium salt, if I react it with Cu2X2 and X here, bacha, is just your chlorine and bromine, then you will get this kind of halide. What is happening? This entirely gets replaced by the halogen atoms. Okay? Here you're getting again sp2 hybridized halide. Okay? Again, but if you want to make a haloarene, iodoarene, then only react Ki with diazonium salt. So if you want to get chlorine and bromine, then react it with Cu2X2. But if you want to make iodine, then react it with Ki. Okay? This is the major reaction. Okay? Next is physical properties. We've done with the preparation methods of both haloalkanes and haloarenes. Do anybody have any doubt? We've done so many examples, PYQs, which were important with them. Now we're going to look at the physical properties. Okay? First thing that is given in your NCERT, bacha, is ki alkyl halides, which is your RX kind of molecule, are actually colorless when pure. However, what happens, the bromides and the iodides, they develop a color when you put them in light. Okay? When they're exposed to light, and many volatile halogen compounds have sweet smell. That is it. That is just a factoid question, and you need to very much focus on the facts, because we are seeing a new trend emerging, which is JEE paper is based on a lot more on the facts right now. Okay? Now next physical properties, number 4 that we're going to study is their boiling point. Okay? Boiling point, what happens to the boiling point of alkyl halides? So they have a higher boiling point than parent alkanes. Parent alkanes means what? If there is a RH and if there is a RX. If you want to compare between the boiling points of these two things, the RX will have a higher boiling point. The alkyl halide will have a higher boiling point than the similar molecular weight alkanes. Why is that the case? Because I just told you this alkyl halide is a polar bond, right? So here the intermolecular interactions actually are increasing. What is happening? So this alkyl halide molecule has now two kinds of intermolecular attractions, which is dipole-dipole interaction, as well as your van der Waals forces. So two kinds of interactions are present in your alkyl halides, while in your simple alkanes, only van der Waals forces are there, as there is no dipole moment. So due to dipole moment, their boiling point actually increases. ठीक है. Now what is the order? Again, van der Waals forces increases with size, right? So as the size of the halide will increase, so will the boiling point. Simple. So here the order is Ri, matlab iodide, alkyl iodides have the highest boiling point, then bromides and chlorides and fluorides. Okay. Now we talked about if we change the fluorine atoms, sorry, halogen atoms. What will happen if you use isomeric haloalkanes? What will be the trend there once again? So here again, bacha, as the isomerism increases, which means what? As the branching increases, can you see? Look at this example over here. This is a simple butane halide, right? This is 1-bromobutane. This is what? This is 2-bromobutane. And this is what, bacha? This is your isobromobutane, right? Can you see as the branching is increasing, as I'm going from here to here, the branching is increasing. When the branching is increasing, the structure is becoming more circular. Can you see this is the more circular structure? So more circular structure actually have the least surface area. So as the surface area decreases, the boiling point also decreases. Understand this thing. Okay? So, bacha, boiling point I'm writing here once again is inversely proportional to branching. So, as the branching will increase, boiling point will decrease. So, it is inversely proportional to branching. Can everybody see this thing? Everybody see this thing? Yes. Correct, Roshni. As the branching increases, boiling point decreases. Hence, this normal butane has the highest boiling point. Then your 2-bromobutane and the isobromobutane actually has the least boiling point. Is this thing clear to everybody? This is the most basic thing that I have to make you understand. Boiling points. Now, again, let's talk. That was alkyl halides. Now, let's talk about aryl halides. Okay, this is an aryl halide. In aryl halides, for example, there can be possibility of 3 kinds of isomers: the ortho, the meta, and the para. Right? This is the ortho isomer, this is the meta isomer, and this is the para isomer. Everybody understands what's ortho, what's meta, what's para. Right? Now, what happens, bacha, with the boiling point? Let's understand boiling point first. Okay? The boiling point order is the boiling point order. Can everybody see that ortho is more than meta is more than para? What is the boiling point order? Okay, I'll write it here. Ortho is more than para is more than meta. So this is the boiling point order, right? Ortho, then meta, then para, then meta, right? Why this happens? Because bacha, in ortho there is a lot of what? Interactions are happening, correct? So here there are more interactions happening in ortho, hence the boiling point is actually the maximum. But what? Because, sorry, boiling point also depends on one more thing, which is your dipole moment, right? Can you see that ortho, bacha, has the maximum dipole moment, right? And then your meta and then your para. Okay, but this is the order followed. Next is your melting point. Melting point depends upon the crystal structure. Okay, it always depends upon the crystal structure. Okay, so can you see that more symmetrical the crystal structure is, more will be the melting point. Okay, more symmetrical the crystal structure, more will be the melting point. Hence, bacha, here what happens? Can you see? The para has the highest melting point, then your ortho, and then your meta isomer. So this is the final order followed. Okay, everybody is understanding this? Yes. Can I move forward? Please write down these trends. Next is your again previous year question. The correct order of melting point of dichlorobenzene. Exact question from the NCERT. See, this is JEE Main 2023 question. Who can answer this? The correct order of melting point of dichlorobenzene. This is exact question from NCERT. NCERT question once again. Yes, answer this question for me. Answer this question for me. Answer this question for me. I'm looking at the chat box. Roshni has answered 4. Para and then ortho and then meta. Very, very good, Roshni. And then R. Naga Abhishek has also answered D. Mukesh has answered. Jana has answered Gryffindor. Jeevan has answered. Very, very good. So, what is the Melting point order is para because it is the most symmetric, then your ortho, and then your meta isomer. Very, very good. This is the order followed. And the correct answer is fourth. Let's move forward. Next, physical properties, density. So all these properties are important. Can you just see, look at this structure? Very important, and hence questions are asked from here. Next is density. What happens to density, bacha? Again, very common knowledge, ma'am. As the mass will increase, so the density will increase. This is very common knowledge, right? So as the mass will increase, density will increase. Now let us look at few of the points given in your NCERT. One of the point is कि बच्चा the RF and the RCl, ठीक है? Your alkyl fluorides and alkyl chlorides are actually lighter than water. Very important point. But your alkyl bromides and alkyl iodides are heavier than water. ठीक है? Alkyl bromides, iodides, and even your polychloro compounds. Okay? Your polychloro compounds are also heavier than water. It means which has more than one chlorine atom attached to it will be heavier than water. Otherwise, this is the trend. Now, what is the decreasing order of density? So, as the highest mass is of iodine, right? So, the iodides will, as the mass will increase, density will increase. Hence, Ri will be the most dense molecule, then RBr, then RCl, then RF. Easy. Again, this question, same question was repeated. The density order was asked in JEE 2023 exam. The question is not included in here, but I'm telling you, same density question was asked in your exam. So density order also very important. Next is the solubility order. What do you think about the solubility of alkyl halides? This is the molecule. What did I tell you? This is a polar covalent molecule, right? But the polarity is not that much, right? What happens here? What happens, bacha? They are only slightly soluble in water. Slightly soluble in water. Why? Because they are unable to form hydrogen bonds with water. Number first reason, right? ठीक है? RX are polar covalent compounds, but insoluble in water, because they cannot form H bonds, which means to form H bonds, what they have to do? They have to break the RX bond and form new bonds with water molecule. Okay? So what actually happens, the new bonds that are formed have actually lesser energy than the old bonds. Hence, this is not a very good thing to do. It means it is not a spontaneous kind of reaction, very slightly soluble, but it is very much soluble in organic solvents. They dissolve in organic solvents. Another important point. Next is stability. Stability, which means what? Which is unable to react, right? Which is the most difficult to react. So this order will be the directly opposite to the reactivity order. So more smaller the molecule, more smaller will be the bond form, and more stronger will be the bond, right? So because fluorine has the smallest atom, therefore it will form the smallest bond, therefore it will form the strongest bond. Hence this is the most stable molecule. Hence alkyl fluorides are more stable than chlorides, bromides and iodides. Okay? Again, remember one thing, alkyl iodides which are the least stable. They decompose. If you give them even a little bit of light, they decompose into iodine, and they themselves become what? Themselves become a alkane compound, just like this. Okay? Okay? Beta, I've taken so many detail. If you just check out the channel, right? I've taken a detailed session starting from the organic chemistry. Then I took the GOC sessions where I discussed in very much detail the acidity, basicity orders. I took 2 classes of that. I've taken so many sessions. I've taken the hydrocarbon session, and for the normal organic chemistry, I've taken at least 3-4 sessions just for your JEE 2024 attempt. So go and check it out. In this month and within the previous month, that's 2 months, I've taken so many classes. Chalo. Next, we're talking about the chemical reactions of haloalkanes. Till now, we have covered a lot of things. What were the things that we covered, bacha? We started with what does haloalkanes and haloarenes look like, which have the sp3 hybridized molecule, which have the sp2 hybridized molecule. What is the nature of the bond, the polarity of the bond? What is the dipole moment, right? This is the how we started. Next, we went on to the methods of preparation. How to prepare haloalkanes. What were their methods? Okay? ठीक है, substitution methods, by using alkenes and addition methods, by using free radical mechanism, by using halogen exchange, so many methods we discussed. Then how to prepare haloarenes, just remember the order in your head. Haloarenes, how did we prepare? We did two kinds of reactions, like one was a diazonium salt reaction, ठीक है, all these Sandmeyer reaction, all of these reactions we did, ठीक है. The next week we talked about their physical properties, boiling point, melting point, density, solubility, all these things we talked about, right? Now we are talking about their chemical reactions. This is the last part of this chapter. What are the chemical reactions, bacha? Number first, your haloalkanes. We talk about one thing one by one. First, we'll talk about haloalkanes. Then we'll talk about haloarenes. Now we're talking about haloalkanes. They actually show three kinds of chemical reactions, which is nucleophilic substitution, elimination reaction, and reaction with metals. What is nucleophilic substitution? Some kind of reaction we've already discussed. What is a nucleophile? Anything which has a negative charge on it is called a nucleophile. Correct? Now substitution means what? That we are substituting one group with the other group. For example, I taught you the ROH. What was happening when I was reacting the ROH with some of the Br2 compound, for example, है ना? What was happening? This was getting replaced by the Rx compound, isn't it? Isn't it? In nucleophilic, what was happening? One was leaving and the other kind of negative charge was attacking over here, है ना? These kind of reactions we studied. In case of Br2, let me write some kind of HBr or some kind of shit like that. HX, ठीक है? Here, ठीक है? This is the bacha nucleophilic substitution. You're substituting some of the thing. Elimination, what? You are eliminating something, which means what? For example, this is H, this is your X, and this is a kind of haloalkanes. Okay, I've made a haloalkane. Now to this haloalkane, what am I doing? I'm eliminating. What am I eliminating? Majority of the cases, I'll eliminate this HX compound. है ना? This HX compound I'll eliminate. Hence, the product that I will get is a alkene. This is what I'm eliminating. Two of the atoms I'm eliminating, and hence a multiple bond is formed. This is the elimination reaction. Reaction with metals, whatever you do, you take a alkyl halide and react it with any metal. For example, sodium, right? Mostly sodium, magnesium. These kind of metals you're going to do reactions with. Correct? 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 Next is chemical reactions of haloalkenes. Number first, we're talking about nucleophilic substitution reaction. So because we're talking about reactions of haloalkenes, so here I took a haloalkane. What do I know about this haloalkane? That, ma'am, one, because the halide is more electronegative, hence it will get a delta negative charge on it. Therefore, the carbon directly attached will get a delta positive on it. Now, a nucleophile has to attack. Nucleophile, always remember, what is a nucleophile? Anything which is electron rich. It will either have a negative charge on it, or it can also have a lone pair of electrons on it. In either of the cases, it is what? Electron rich. So what happens? This electron rich species can now attack the positive carbon, right? Always remember the arrow, the reactions always follow from the negative to positive. Only electrons can attack the positive charge. Hence, what happens? This gets replaced because it is substitution reaction. So this halide will be the leaving group. This is what? Because this is leaving the compound, hence it is called a leaving group. What it is called? It is called a leaving group. Okay? And you get in exchange this kind of product, CCNU product, and the X minus over here. Okay? So this nucleophile attaches itself over here. So this is the basic reaction that happens. Ki one is the leaving group which goes away and the nucleophile gets attached to the carbon atom. Okay, I know. But what is the mechanism? How does this happen? So it actually takes place through two kind of mechanism which you are very familiar about, SN1 and SN2. Let us look at those mechanisms. Okay, before that, this is a very important table again given in your NCERT, hence I've included over here. So this nucleophile, what did I tell you about the nucleophile? कि मैम न्यूक्लियोफाइल is something which either has a negative charge or a lone pair of electrons on them, and we know the alkyl halide will remain the same. It can be anything, it can be any Rx, and hence this X will get replaced by so many nucleophiles. So what are the examples of nucleophiles? Ma'am, I know that the X can either be fluorine, chlorine, bromine or iodine, but what can be the nucleophile? Nucleophiles can be these many things. For example, if in your question NaOH or KOH is given, what are these strong bases? Strong bases means what? They easily give away OH negative ions. Can you see the negative charge on them? Hence, it is a nucleophile. Hence, what will be the product form? This X will go away and a ROH will be formed, which is an alcohol product. Okay, everybody is understanding this? Next nucleophile is water. Why is water a nucleophile? Because the oxygen has lone pair of electrons, isn't it? Again, electron rich. Hence, here, what is the nucleophile if somebody asks you? The water itself in a whole is a nucleophile because the oxygen atom has the lone pair of electrons in them. And what will be the product form after reaction with any alkyl halide? It will be the ROH product. Similarly, if you take a NaOR product, R means what? Any alkyl, you have taken a loss of HBr, right? Yes, but a loss of just X minus ions, not HBr. What are you talking about? What are you talking about? Yes, Tanishka is right. No, just X is loss, not the HBr. Only, Bacha, can you not see this? Only X goes away. Only the X minus is going away and leaving behind the carbon with the positive charge on it. So carbon with the positive charge, this nucleophile attacks on it. Correct? Correct. Now next is NaOR product. Now what is a nucleophile here? The nucleophile is RO minus nucleophile. Okay? The RO minus nucleophile, hence the entire RO minus attacks over here and it will form a ether kind of product. Similarly, if the reagent is NaI, again it can get separated into Na plus and I minus, right? Because this is an ionic product. So I minus is the nucleophile, again the I goes there and we know what is this reaction called? Finkelstein reaction, hence alkyl iodides are formed. Similarly, NH3. Why is NH3 a nucleophile? Because the nitrogen over here has a lone pair of electrons, right? This lone pair of electrons can attack the positive carbon over there. Okay? Here, again, the nucleophile is actually the entire nucleophile, the attacking species, and the product that you will get a primary amine. What are you getting? You're getting a primary amine. Similarly, if you take a primary amine and then you try to react it with alkyl halide, you'll get a secondary amine. With a secondary amine, if you try to react it with alkyl halide, you'll get a tertiary amine. Is this thing clear to everybody? Again, in this, whatever are nucleophiles which has either a negative charge or a lone pair of electrons on them. Correct? Next is nucleophilic substitution reactions. Again, so many more examples are there. Very important examples are these examples. Okay? For example, look at KCN. KCN is what? KCN is a ionic species. It splits into K plus and Cn minus ion. So here the nucleophile is here Cn minus, right? So here Cn minus is the nucleophile. And what happens? What is the product form? The product form is actually RCN product, which is also called the nitrile or the cyanide product. But now just look at the another kind of reagent. The reagent is AgCN. AgCN, silver cyanide. Now this is no longer a ionic species. This is actually a covalent species. Remember this thing. So with covalent species, what is a nucleophile? The entire thing is a nucleophile. Can you see? The entire thing is a nucleophile. And here nitrogen has a lone pair of electrons in them. Hence, but with AgCN, the product form is actually an isocyanide. While with KCN, the product form was a RCN product. Can everybody see that? Here the attaching atom with AgCN is nitrogen. But with KCN, the attaching atom was carbon to the carbon. है ना? Here again, just look at both of these examples, KNO2 and AgNO2 example. Here again, what is happening, bacha? Again, see these kind of nucleophiles like the CN nucleophile or the NO2 nucleophile. What are these nucleophiles called, bacha? These are called ambident nucleophiles. What are they called? Ambident nucleophiles, which means what? Ki they have two positions. they have two positions which can function as a nucleophilic position. Here the carbon can also donate its electrons and the nitrogen can also donate its electrons. So this is an ambident nucleophile, which means with two places it can donate the electrons, but at one time only one does it. Okay? So whenever the Ag, for example, look at KNO2 and AgNO2. With KNO2, the attacking position is actually the oxygen position, while again with AgNO2, the attacking position is again the nitrogen position. So what you have to remember here, you have to remember that whenever in exam silver is written, silver with Cn, silver cyanide or silver nitride, then in the product the attacking position will always be nitrogen position, right? The nitrogen position will be the attacking position in case of silver. Okay? And in the case of ionic species, the another one, the opposite one will be the attacking position. So with silver nitrate you get a nitroalkane, with potassium nitrate you get a alkyl nitride. Similarly with RCOAg, the attacking agent is, the nucleophile is RCO minus, and you will get a ester product. And with LiLH4, the nucleophile is actually hydride ion, remember this, and you will get a normal alkane as a product. With R minus M plus, what is R minus M plus? Any metal ion. As you know ki metal is a very electropositive species, isn't it? So with the electropositive, because metals are very electropositive, hence the alkane group attached right next to it will always get a delta negative charge, isn't it? Because see, whatever metal is attached, because it is more electropositive, it will always get the positive charge on it. Hence the carbon atom will get the negative charge on it. Hence the nucleophile here is evident, it is R minus. Hence with this, what will be the product? Again a normal alkane will be the product. Everybody understood this? Everybody understood this? ठीक है? Now let us look at this question. Haloalkanes react with KCN to form alkyl cyanides. We just saw that as main product, while AgCN forms isocyanates. Why is that the case? What did I tell you? When I react any alkyl halide with what I'm reacting, for example, KCN I'm reacting with KCN. What is the product form? With KCN what happens? Because this is an ionic molecule. Remember this, KCN is an ionic molecule. Hence it breaks into Cn minus and K plus ion. Okay? Now what is happening? Because this Rx will get what? This will get a delta negative charge. This will get a delta positive charge, right? And hence this is the leaving group. If this X minus leaves, it will leave behind a positive alkyl group over here. So this negative wala can attack this positive species. But how does the reaction happens, bacha? The attack here happens through the carbon position, just like this. Okay? Carbon position, why does it happen, bacha? Because carbon is a lesser electronegative atom. Remember this thing. Here, what is the species formed after the ionic separation? Cn. Here are 2 electrons present. Correct? Here are the 2 electrons present and carbon has a negative charge on it. Correct? This cyanide atom actually undergoes what? This can undergo your resonating structure. This is one structure of cyanide. The other is, for example, what can happen? For example, this bond can go over here and this can actually get C double bond. Sa minus structure over here. So this is actually a resonance structure among this. This can actually become a resonating structure just like this. Can you see these have 2 resonating structures? So in one case, the negative charge is on carbon atom. It's on carbon atom. So bacha, always remember one more thing. Between carbon and nitrogen, this is a carbon, this is a nitrogen. Which one is more electronegative? Which one is more electronegative? Nitrogen. Electronegative means what? It holds the electrons more closely towards it, right? So nitrogen is holding electrons more closely, hence the electrons are not available to donate. While carbon is lesser electronegative, it donates the electrons easily. Hence with the ionic compound, RCN is the product because carbon donates the electrons easily. So this is the product formed with KCN or the ionic compound. But if what happens, I'm removing this. Everybody understood this part? I'm removing this. ठीक है? Chalo. If there are no questions, If there are no questions, then I am moving forward. And if I'm trying to react with AgCN, AgCN is a covalent molecule, isn't it? AgCN is a covalent molecule. I'm trying to react with your Rx. Again, the X will get the delta negative, R will get the delta positive charge. Correct? Now what will happen? The X will go away. Then what will be the product? This AgCN molecule over here, it is a covalent bond between carbon and silver, right? So this bond will not break, So what will happen? The nitrogen has a lone pair of electrons on it. Hence, now the attack will happen through this lone pair of electrons to this atom of carbon. Okay, so this kind of attack happens. Hence, what happens? The R here NC kind of product is formed, which is your isonitrile product. Because AgCN is a covalent molecule, hence this Ag and carbon bond is not broken. Then what can attack this positive carbon? The lone pair of nitrogen actually attacks the positive carbon, hence the product form is actually a isonitrile product. But with the ionic case, the product form was a normal nitrile product. Is this thing clear to everybody? Yes, now the carbon is not free. Yes, Jeevan. Understood? Understood? Okay, very easy concept. Let's move on to the next thing. Previous year question on your screen once again. Assertion. Haloalkanes react with KCN to form alkyl cyanides as a main product, while the AgCN form isocyanide as the main product. Reason: KCN and AgCN both are highly ionic compounds. What do you think is the answer? Is this assertion true? Haloalkanes react with KCN to form alkyl cyanides and AgCN they form isocyanide. Is this assertion true? Ma'am, after the attack of nitrogen, how does AgC bond break? Because bacha, all the bonds are fulfilled. All the valencies are now fulfilled. So the Ag bonds now break. See what happens. Let us move back. So now she is asking ki ma'am, how now the Ag bonds break. So bacha, as you can see, once again what happens? This is the Ag atom over here. Okay, because Ag is again what? Ag is a metal. So metal will obviously always have the delta positive charge on it, right? And here all the bonds are satisfied for the carbon here as well. So now here what happens? This bond actually can break after this is attached over there. Okay? So this breaks in the end. Now who can answer this question? A is true, R is false. Somebody's answered. So many people have answered. R is wrong, KCN is correct because only KCN is the ionic compound. True, true. This is true. This is false statement. Correct. This is again JEE 20. See, many easy questions. All the questions based on NCERT concept was asked in JEE 2024. I don't know why. So easy paper. Now, but I don't think the April paper is going to be that easy. Okay. Next is previous year question, JEE 2024 once again. Alkyl halide is converted into alkyl isocyanide by reaction with. Yes. Who can answer this question for me? Answer this question for me. I'm looking at the chat box. I'm looking. Yes, everybody was right about the previous question. So I've got the first answer by Farhan, which is D. Naga, D, AgCN, D, AgCN. Very, very good. Very good, very good. The answer is AgCN. We just discussed everything about it. Correct, correct. Chalo. Chalo next. Chemical reactions of haloalkanes. So I just told you these were the substitution reactions. What was happening? The alkyl halide, right? What was happening? We took the alkyl halide and you were trying to replace it with another nucleophile, isn't it? This was attacking over here. And you were forming another R nucleophile kind of compound, isn't it? This was the reaction. Now, bacha, what happens? I told you that this is the basic reaction. But this reaction happens through two kind of mechanisms. Number one is the SN2 and the another one is the SN1 reaction. So what are the properties, what are the features of all these reactions? Let us look at one by one. Bacha, this is, can you see the 2 over here? The 2 represents that this follows the bimolecular kinetics. Bimolecular means what? This reaction, this is a reaction How many reactants it has? It has two kinds of reactants. One is the alkyl halide, the other is the nucleophile, isn't it? So in SN2, because it is a bimolecular reaction, the rate of the reaction depends on both of these reactants, which is the alkyl halide and the nucleophile. Remember this thing. Okay? But in the SN1, what happens? This is a unimolecular reaction, which means what? That the reaction only depends on one of the reactant, which is just your alkyl halide. Remember this thing. Only on alkyl halide the reaction depends. No matter what your nucleophile is, how much your nucleophile is, it doesn't depend on that. Only on alkyl halide SN1 reactions depend, while SN2 depends on both the kind and the how much amount of nucleophile you have. The kind of nucleophile you have, the rate depends on both of that. ठीक है? Next, let us look at all of these things once again. SN2 reaction we're going to look at one by one. Number first, we're going to look at SN2 bimolecular reaction, where the rate depends on both the alkyl halide and the nucleophile that is attacking. Correct? Let us look at that. For example, again, look at this example. This is CH3Br alkyl halide. I am reacting it with the reagent NaOH. I again told you this is a reagent. What is the nucleophile of NaOH? Well, it is a very good base. Hence, the nucleophile is OH negative species, right? So, what will happen? The Br will go away and it will be replaced by the OH species, right? And you will be left with NaBr. Is this thing clear? Now, what is the mechanism, how it happens? So, always remember one more thing. In SN2, it is a bimolecular. The rate depends on both the reactants. But it is a single step reaction. What kind of SN2 reaction is? It is a single step reaction. Single step reaction, which means what? It happens in just one step. The number first is, this is the alkyl halide. Now the alkyl to the alkyl halide, the nucleophile, the negative species is trying to attack, is trying to approach. Now what happens? There is a transition state formed. Can you see a transition state is forming over here? Where what is happening to this carbon, these three hydrogens are attached. The 1, 2, 3, all of these hydrogens are attached. So all these hydrogens attached to the carbon are planar, are in one plane. Remember this thing. So all the CH bonds are in one plane. Remember this thing. Okay? All the CH bonds bacha are in one plane. Okay? And what happens ki as the OH is attacking, the nucleophile is attacking, and so as the leaving group is leaving there. Okay? So this attack and this leaving group. So what is happening? This new bond is forming and the old bond is breaking. This step takes away. Simultaneously it happens. Ekdam simultaneously this step happens. Okay? Now, bacha, can you see in the transition state the carbon is actually has 5 bonds. Hai na? Can you see the carbon has 5 bonds to it? Hence, it is a very, very unstable species. The transition state hence is very, very unstable. It is so unstable that it can never be isolated in an experiment. Which means you cannot ever isolate a species. You cannot ever take out this species within the reaction. So this is only a hypothetical. Scientists assume nobody has ever seen this species being formed. Okay? Now, bacha, what happens? The OH is attacking from the back. Can everybody see? And this Br is leaving from the front. So the attack is happening from the back. This is a single step reaction. Hence, here what happens, bacha? What happens stereochemically, that this is a inverted product you get. What kind of product? Inverted product, which means what? The first Br was attacked to the right hand side, but now the nucleophile attacks from the back and it is now attached to the back hand side, right? So here an inversion of configuration takes place in the SN2 mechanism. All of these things you need to keep in mind. ठीक है? ठीक है? Everybody understood this? Everybody understood this? Chalo, next thing. People are making fun of me. They're saying ki, do I look like a 16-year-old really? Really, students? Somebody is saying I look like a 16-year-old. What do you think is my age is? I want you to guess in the comment section. Yes, Roshni, you're correct. What do you think my age is? I'm actually like more than probably 12 to 13 to 14 or 15. I don't know how many are older than you guys. Chalo, next. Now, what is the reactivity order followed for this species? As I told you that the reaction happens from the back side, right? So, because the nucleophile is attacking from the back, so what should be the criteria? The criteria should be that the back side should be, bacha, there should be no steric hindrance there. There should be no 25, 24, 25. But beta, I'm very older than that age actually. 25 plus. Yes, that is true. I'm 25. Yeah, I'm much older than 25, 26. Chalo, let's not go back. No, let's not go there. Just understand this thing. ठीक है? Now, because attack is attacking from the back, the nucleophile is attacking from the back. What actually happens, bacha? There should be no steric hindrance over here. Hence, the reactivity order followed is methyl ion will be the most reactive, then primary alkyl halide, then secondary alkyl halide, and then your tertiary alkyl halides. Why? You can see through these diagrams. Can you see in the tertiary alkyl halides, there are three kinds of hydrogens attached over here, 3 methyl groups attack. Hence, there is so much of steric hindrance. Hence, the nucleophile cannot attack in a very good amount. Similarly, in secondary, there are 2 methyl groups. Hence, again, it is very sterically hindered compound. Here, there is again 1 methyl group. It is again sterically hindered more than the methyl group. Hence, this is the order followed for the SN2 mechanism due to steric hindrance. Okay, due to steric hindrance. ठीक है, stop guessing my age now, बच्चा. चलो, ठीक है, everybody understood this SN2 reaction? Yes, Tanisha, you are somewhat right. Somewhat right. चलो, ठीक है. Now SN2 is favored by, बच्चा, what? SN2 is favored by what kind of things it is favored by? I told you what is the reactivity order, because the species which is more sterically hindered will experience the least SN2 reactions. What are the other factors SN2 reactions depend upon? It depends upon whether there is a strong nucleophile. I told you SN2 is a bimolecular. It means its rate of reaction depends upon the kind of nucleophile attacking. Hence, strong nucleophile. Strong means what? For example, the OH minus nucleophile, or your I minus, again very strong bases. Strong nucleophiles means what? Which is a very strong base. So strong nucleophiles like I minus, Cn minus, aqueous KOH will again give you OH negative ions. Okay, so these will favor the SN2 reactions. Next is polar aprotic solvent. I again told you polar means it has some kind of polarity in it. For example, acetone. What is the structure of acetone? The structure of acetone is CH3, C double bond O, CH3. Okay, here the acetone has a polar structure because oxygen is more electronegative. Hence, it has a polarity in this direction, isn't it? Similarly, DMSO has a structure like this. DMSO, the carbon is replaced by sulfur. Otherwise, the structure is same. This is again a polar structure, right? Polar aprotic means what? Which cannot give the H plus ion. Protons means what? Proton mean H plus ion, right? Aprotic means which do not have any H plus ion. So, any polar aprotic solvent, bacha, will favor the SN2 reaction, right? Once, sorry, this is booked for me. No, it's booked for me. You can check downstairs. Yeah, sorry about that. Okay, now bacha, we're talking about the good leaving groups. If again leaving group means what? The I minus is a very good leaving group, then Br minus and Cl minus and F minus. Sorry for the delay, sorry for the disturbance. Okay, I minus, I always told you I minus is what? It's a bigger molecule, hence it is very easy to leave. The bond is easy to break, hence I minus is a very good leaving group, then Br, then Cl, then F. The leaving group, bacha, order will be followed. The same leaving group order will be followed even for SN1, because leaving group depends only on the bond breaking, right? So it is easier to break the Ri bond, isn't it? The Ri bond is easier to break. Hence the leaving group order will always remain the same. But just remember, in polar aprotic solvent, SN2 reactions are favored, and also strong nucleophiles also favor SN2 reaction. Is this thing clear to everybody? These things you have to keep in mind. Okay, I will teach you with examples more about these things. Now let us look at the important examples of SN2. What is SN2? Again, just concentrate in your head. SN2, ma'am, 2 means it is a bimolecular reaction, which means the reaction rate depends on both the alkyl halide and the nucleophile. Understood? It is SN2, which means it is a single step reaction. Single step means what? There is a formation of transition state, ma'am. Understood? If there is a transition state happening, it means the attack is happening from the back side. It means inversion of configuration will be the ultimate product. Understood? Now, what is the reactivity order of alkyl halide? So, alkyl halide reactivity order is that the methyl alkyl halide more reactive than primary, then secondary, then tertiary. Why? Because of due to least steric hindrance, hindered will be the most preferred that thing. Now next, other factors on which SN2 depend was it should have a strong nucleophile favors SN2. Next is polar aprotic solvents favors SN2, and next is the good leaving group. So this thing is clear in my head. Now let us look at the examples. Important examples is again the KCN and the AGCN that we studied. But here what happens? The cyanides attack from the backside. Here also the attack happens from the backside, and the Br leaves from here, the Br leaves from here, and this kind of product is formed, correct? So what product will be formed here? The inverted product, isn't it? Inverted product, inversion product will be formed because the attack is happening from the backside. Why does it happen? Once again, CN is what? It is a very strong nucleophile. I just told you, when it is a strong nucleophile, it will favor SN2 because CN is a nucleophile, hence it is a SN2 mechanism. Similarly, in the nitro group, which is KNO2 or AgNO2, in both the cases, again, SN2 is followed. Why? Because again, bacha, NO2 is a very good nucleophile, strong nucleophile. Hence, attack happens from the back. Here, the attack will happen from the back. And this kind of methyl nitrite is formed here, nitromethane. So, these are very good examples of SN2. I will give you more examples. Let us look at this. For example, your Williamson ether synthesis. You will read about it in alcohols, phenols, and ether. I'm going to teach you once again. Do not worry about it. Again, what is the nucleophile in Williamson? It is the RO minus nucleophile. Can everybody see the RO minus? Is it a good base? Yes, ma'am. It is a very, very good base. Why? Because R base means what? Nucleophile means what? Here it is. The R is actually giving electrons to the oxygen, right? And this attacks this R, and hence the final product formed is the ROR ether product, which again happens through the back attack. Back attack means what? This is a SN2 mechanism. The other reactions are, whatever reactions we studied, the Finkelstein reaction. You remembered? Finkelstein. Finkelstein is also a SN2 reaction. Okay? Next is your Swartz reaction that we studied. We studied the Swartz reaction, right? The Swartz reaction is also a SN2 reaction. Also add these two reactions in the SN2 example list. Okay? Ma'am, can you ask Amrita ma'am to enter the class time? Beta, probably Namrata ma'am is not going to take the class today. Probably Namrata ma'am is actually sick. She got viral. So I think she is not going to take the class. Most probably not. If she does, she will reschedule it. I will let her know. Okay? Chalo. Next, SN1 reaction. SN1 reaction means what? Again, what you have to know. It has a SN1 in it. 1 means it is a unimolecule. It depends on just one thing, which is your alkyl halide. The reaction rate depends on just the alkyl halide. For example, this is the reaction. CH3CBr OH minus. OH minus is a nucleophile. What will happen? The Br will go away and the OH will actually replaces, because it is a kind of substitution. The Br is getting substituted by OH. So what is the mechanism of SN1? So bacha, as your SN2 was a single step reaction, SN1 is actually a two-step reaction. two-step reaction. Remember this thing. SN2 is actually a two-step reaction. Okay? Now look at the mechanism given over here. The mechanism is, this is what, bacha? This is CH3CBr, which is a kind of tertiary alkyl halide, isn't it? Tertiary alkyl halide. So bacha, in this, number first step is the formation of carbocation. Can everybody see what happens? The Br leaves, the Br minus leaves, and it leaves behind a positive charge on it. So this is a slow step, rate determining step. It means that more stable the carbocation, only there the reaction will take place. Okay? So it means what? That the reaction will take time to form the most stable carbocation. Here carbocation formation happens. Now the next step is the addition of the nucleophile. Then the nucleophile gets added over here. Okay? In this case, and then this is formed. So what is it? Again, this is a two-step reaction, ma'am. In first step, the carbocation is formed. The next step, the nucleophile attacks. Now, what is the stereochemistry of this reaction? Let us look at that. So, bacha, what did I tell you? What did I tell you? Ki after this Br minus leaves, the Br minus leaves, right? So, after this leaves, a carbocation is formed. Carbocation is what? Let us look at the structure of carbocation. Carbocation has CH, CH, CH and a positive charge over here. What does it mean? A carbocation is just a 6 electron species. Can everybody see? Which means its p orbitals are completely empty. Huh? Its p orbitals are completely empty. Can you see? Now the approaching nucleophile, which is the OH negative ion. This nucleophile there is a 2 p orbitals. P orbital has a lobe-like structure, one above and one below. So this OH minus can now attack either the above p orbital or the below p orbital. And the chances of attack are absolutely same. It can either attack the above or the below. Okay? So in this case, bacha, what happens? Two kinds of products are formed. One is the inverted product and one is the retented product. What kind of product? For example, here this one is actually, okay. So in this, two kinds of products are possible. One is the inverted product and one is the retention product. Retention of configuration, and number second is the inversion of configuration. Retention of configuration and the other one is the inversion of configuration. Okay? Why are you crying, Jeevan? What happened? What happened? Why are you crying? This everybody understood? Okay? Inversion means what? Ki the stereochemistry will either invert or it will remain the same. Both are the possibilities. Sometimes what happens? Sometimes that happens. So these retention plus inversion kinds of products are actually called enantiomers of each other. Now look at these two products. Enantiomers means what? Ki they have the same bond attachment, but they are not mirror images of each other, right? They are not mirror images of each other. This is not a stereochemistry class. I will not explain to you any further. Just look at this reaction. For example, these are mirror images of each other. If the R is here in this molecule, the R is here, right? If the H is here in this molecule, the H is here. If the CH3, if the CH3 is here in this molecule, the CH3 is here. So what are these? These are actually mirror images of each other, like how you see in the mirror to yourself, right? But these are not superimposable. You cannot superimpose them on each other. Such like your hands. Can I superimpose them on each other? No. They do look like same if I look them in the mirror. They look like the same thing. But if I'm trying to superimpose, keep one over the top of the other, they're not able to superimpose. These are called enantiomers. Now what happens if the inverted product and the retention product percentage are same? For example, the S product formed is also 50% and the R product form is also 50%, right? Then when both the products are 50-50 equal percentages, then such a mixture is called a racemic mixture or racemization. Only when the enantiomers are equal in percentage. Remember this thing. This is also 50%. This is also 50%. Okay? Optical, non-superimposable. Yes, these are optical isomers. Enantiomers, non-superimposable on each other. Correct? Everybody understood? Since Amrita ma'am got eyes open. Thank you, Jeevan. I will let her know that you were praying for her. Okay, everybody understood? Now, what is the reactivity order of alkyl halides? It is exactly the opposite of the SN2. In SN1, what we are making? In SN1, we are making a carbocation. Which is the most stable carbocation? Tertiary. Hence, tertiary will be the most reactive. Hence, the reactivity order is actually tertiary is more reactive than secondary, then primary, and then methyl. So this is the reactivity order followed because carbocation is formed. But in SN2, the reactivity order was totally opposite because there we were considering steric hindrance, right? Due to more stability of tertiary carbocation. Next is what are the other factors which favor SN1? Okay? For example, the nucleophile here should be weak. A weak nucleophile, for example, the ROH nucleophile is a weak nucleophile. Similarly, the H2O nucleophile is a weak nucleophile. Okay? All these are weak nucleophiles. The next is your polar protic solvents actually favor this. There were polar aprotic solvents of favoring the SN2 reaction. SN1 is favored by polar protic. Both are favored by polar. But that was aprotic. This is protic means which easily gives away the H plus ion. For example, the H2O, the methanol, the ethanol, which can easily give away H. See, you should understand protic as which easily formed H bonds. Okay, for example, methanol molecule is CH3OH molecule. This can easily form oxygen is here, right? This can easily form H bonds with another water molecule, isn't it? Isn't it? So wherever the H bond formation can take place easily, such things are called polar protic solvents. Otherwise, to understand which can easily give away H plus. Okay, to just understand that. Otherwise, the basic definition is which can form hydrogen bonds. Okay. Now, other good leaving group, same as the SN2 reaction. More good is the leaving group. More will be the SN1, SN2. Same kind of thing is followed over here. Everybody is understanding this? Now let us look this previous year question, JEE Mains 2024. Sorry. Which among the following halides will not show SN1 reaction? Which will not show SN1 reaction? Who can answer this question for me? SN1, what is the criteria for SN1 reaction? Ma'am, I know that in SN1 actually carbocation is formed. So whichever will be the most stable carbocation will show the maximum SN1 reaction, right? So what is the answer to this question? Fourth option, Jeevan has answered fourth option, which means B. Are you answering B, bacha? Jeevan has answered option number C, only B. Okay, very good, Jeevan. Tanishka has also answered B. Okay, very good, Tanishka. Roshni has answered 1. No, bacha, Roshni, no, bacha. Here, SN1 means what? Where the carbocation form will be more stable. See, here if I remove the Cl, the carbocation formed will be this. What kind of carbocation this is? This is a allylic, very stable by resonance, right? This can move over here and the positive charge can move over there, right? This is a allylic carbocation, very stable, and this cannot be the answer. Again in B, if I remove this chlorine, the positive charge will come over here, right? Positive charge comes over here means what? This is a vinylic carbocation, very unstable carbocation. Hence, SN1 will not be shown only by B. Here again, there is a benzylic carbocation formed if the Cl goes away. Again, stable carbocation. Here again, secondary carbocation is formed. Again, a stable carbocation. Only in this is the forming of vinyl carbocation, which is actually a unstable carbocation. Correct. Very good. Next question, JEE Mains 2024. Which of the following halides will not show SN1 reaction? Sorry. Yes. Which of the following halides? Acha, we already done this. Sorry. Next, the correct statement regarding nucleophilic substitution reaction in a chiral alkyl halide. You have to identify the correct statement regarding the nucleophilic substitution reaction in a chiral alkyl halide. So you have been given 4 kinds of statements in which somewhere has written which shows retention, which shows racemization, which shows inversion. What do you think is the correct answer in this? Please read all the statements. Yes, even that was the same question. We've moved on to the next question. D. Retention occurs in SN1 and wow, racemization occurs in SN1. Jeevan has answered D. Anybody else wants to answer? Anybody else wants to answer? D option. Okay. Gryffindor, Tanishka, Roshni, Farhan. Everybody has given me the correct answer. Producer, Game Over Tamil. Very good. Racemization occurs in SN1 and inversion happens in SN2. Correct, correct. We just discussed all of these things. This is my favorite question now. I do not like JEE 2024 questions. I hate those. These are very easy, right? JEE 2024 January attempt was so easy. Okay? But here, I like the 2023, 2022, 2021 questions. Now, do this question. And what I'm expecting is the April attempt paper is going to be more difficult than the January attempt, which means that you should expect questions like 2023 batch. Chalo, let's go. Who can answer this question for me? Who can answer this question for me? Mahesh has answered A. A. See, what have you given? You've been given some alkyl halides. Okay? Alkyl halides and a nucleophile you're trying to attack to them. Okay? A nucleophile you're trying to attack. So these are two reactions given to you. This is the number first reaction. This is the number second reaction. Okay? And they are asking where the reaction will be first order and where the reaction will be second order. First order means what? First order means SN1, right? Second order means SN2. Why? Because it's SN2, it depends on two things. So it is a second order reaction. You learn that in chemical kinetics, right? Now answer me. Which will follow the first order reaction? Which will follow the second order reaction? Okay, I've received answer by Mahesh, Jeevan. A answer they have given. Game Over Tamil has given me B answer. Roshni has given me D answer. Sawyer, beta, I think there will be no maths class because ma'am is sick today. D as benzylic. Chalo, I will tell you how to approach this question. So what happens in the SN1 thing? SN1, what happens? Carbocation is formed. Right, carbocation is formed means what? If I remove this chlorine, here the positive charge will come. Again, here if I remove this chlorine, the positive charge will come. In both the cases, these are, bacha, what? These are benzylic carbocations. Hence, they are stable. But can you see there are some groups attached to it? Can you see here the methoxy group is attached? है ना? The methoxy group will actually do what? Will increase the electron density, isn't it? This methoxy group can give the electrons towards here and hence can increase the electron density on the ring. Can you see it is doing that? So because it is increasing the electron density and I have a carbocation on me, right? So when it is giving the electron towards the carbocation, what it is doing in return? It is increasing the stability of carbocation, isn't it? So here, bacha, the carbocation is stable, isn't it? In the first reaction, the carbocation is stable due to the resonance of the methoxy group, right? In the second option, what is happening? The NO2 group is attached. NO2 is an electron withdrawing group. It will take away the electrons. So I already have a positive charge on me and you're making me more positive by taking away electrons from me. Hence, I will be less stable carbocation, isn't it? So the more stable will show the SN1 mechanism. So the number first, reaction first will be first order and second will be second order. So the answer is A. Most of the people who have answered A are correct. Ma'am, Prince is asking, ma'am, after finishing 12th drop for 8 months, prepare for JEE is good for bad. What are the disadvantages? Beta, 12th drop means what? Right now you have covered all your 11th and 12th syllabus, the reduced syllabus. Please answer me a few questions about what is your query? What is your query? If you see, how will your preparation, some people are asking, ma'am, is it a good, it is a disadvantage, is it an advantage? But just listen to me. The last thing that I'm going to tell you at this point of time when your exam is just 2-3 weeks away, right? 2-3 weeks away, 3 weeks away. So right now you should focus more on the, first of all, solving the questions, test series. If you have not joined any test series, do that. Even we have a test series. If you do not have anywhere to go, then join that test series. ठीक है, it is an online test series. So the more questions you do, bacha, you will realize what kind of questions I'm getting stuck in, what do I actually know, and I need no help every time my answers are correct. So how will you do that? Only after you solve so many test papers. Number first thing, and also whatever thing you're lacking in, right, this is the time to mostly revise or see the lectures or go to those lectures or ask teachers doubts based on those few concepts. Or if you want to just revise anything and everything in just 2-3 weeks, this is the best time to do that. And on this channel also we're trying to make you do that, right? Ma'am, in current 12th board exam, so bacha, you just took the 12th exam, right? So you didn't take the drop. Yeah, then your preparation must be very good. Just focus on solving more and more test papers, first of all, and also focus on those areas which are weak, which you always do wrong, and what are the silly mistakes you make. Correct? This is the high point to just not give up at this point. Just do not give up. The exam is going to be very easy. I'm again telling you, the only difficult part you're going to get is the maths part, right? I know that. Chemistry, you can totally believe on me. I'm again telling you that there's going to be another series that we are launching very soon. Very soon we are launching within this week. I'm working day and night for it. It's based on most of the organic chemistry concepts, and if we get time before your April exam, we'll also add the physical and the inorganic chemistry to it. But right now it is for the organic chemistry, because many of the concepts that you study, I know in these 1, 2, 3, 4 hour lectures, I cannot make you understand each and every concept, right? Like what is the stability of carbocation? How will you see the anti-aromatic compounds? How will the dipole moment depend on the aromaticity? Many questions are asked on that. Well, just trust me, so many questions are asked from so many areas in organic chemistry especially, that it is basically not possible to make you cover in one lecture. So I am making that series. I'm seriously not sleeping these days so that series comes out as soon as possible. Okay? Beta, to join that test series, there's a link in the description box below. You can go and check it out. Okay? There's a link there. It will be written about the online course, number first. The next number second will be the offline course. If you still do not find, right, please comment on this video after it is over, so that I can privately let you know the link, privately text you and tell you the link if it is not in the description box below. Okay? In the comment section, not in the chat box. Okay? Beta, the new series, yes, bacha, it's for the YouTube only. It's for the YouTube free series. Free series. It will be like 10 to 15 minutes videos covering each and every concept that you can just grasp with so many examples. Okay, with so many examples for you to solve. Correct? Correct? Next. This is done with for everybody. I already explained it to you how to approach this question. Next is choose the halogen which is most reactive towards SN1 reaction in the given compounds. Which is most, thank you so much. Thank you so much. Okay. Choose the halogen which is most reactive towards SN1. Again, SN1 means what? Carbocation formation. So which means what? In every of these options, what you have to see, you have so many, in every of the options, you have two kinds of halogens given to you. Okay, you have to let me know which halogen will show more tendency towards SN1 reaction. Which halogen should be the leaving group so that the SN1 reaction can be shown. See, such a beautiful question asked in JEE Mains 2023. I like these questions so much. Beta, these are about the, right now, what are you looking for? Are you looking for concepts? Right now, what I have prepared, these are based on concepts. For example, first of all, aromaticity. Next is what are the kind of reactions shown. Third is what is the stereochemistry all about. How to detect what is the, and where will be the anti-product form, where will be the syn product form, right? And we are going to cover all the name reactions in them. All the name reactions with their mechanisms, which are important, right? Like in the Finkelstein, I just told you with the SN2 reaction happening. Okay, so like one video related to just one thing. Okay? Jeevan has answered to me A, B, A, B, B, A, B. चलो ठीक है. Choose the halogen which is most reactive towards SN1. SN1. Beta, options are given. Options are given here. A, B. For example, you have to answer for A. Which one will show the most SN1 reaction? Can you see, if I remove this bromine over here, then the positive charge will be created over here. Then this positive charge, what kind of carbocation it is? It is a benzylic carbocation, which is very, very stable carbocation. Hence, here A is the right answer. A will show the SN1 mechanism because the carbocation formed is very, very stable. Next is, can you look at this reagent? Can you look at this reagent? Now what is happening over here? If I remove this I over here, then the positive charge will be created here. Can you see that this positive charge is actually in resonance with here, this double bond, which means what? This is a allylic carbocation. Can everybody see? Allylic carbocation is formed. So with B, again, A is the right answer. Okay? Now look at the C option. Very important kind of compounds. Bacha, here, this is the thing given to you. Can everybody see? This is the kind of structure given to you, and here this is a triangle form. Okay? Bacha, here wherever this kind of junction is there, it is called a bridgehead carbon. What it is called? This is called the bridgehead carbon. Okay? And this bridgehead carbon, bacha, this bridgehead carbon with 3 bonds are there, and this kind of structure is formed, is called the bridgehead carbon. And always remember that the bridgehead carbons can never ever get a planar structure, can never attain a planar structure, which means what? The carbocation, what is the hybridization of carbocation? The hybridization of carbocation is sp2 hybridized, isn't it? It is a 6 electron species. It is a sp2 hybridized. sp2 means it is a planar structure. And I am telling you that at the bridgehead, at this position, it can never make a planar structure. Hence, this will never make a stable carbocation. Here, the B, if the B is lost only and only, then it will make a stable carbocation. So for the C option, B is the right answer. Similarly for D, if I remove the bromine from here, the kind of carbocation formed here is a tertiary carbocation, again more stable. So again for the D, answer is A. So this is how you will see which is the most stable carbocation, which is not the most stable carbocation. ठीक है? C is more unstable. Okay, everybody understood this? Everybody understood this? I'm going to explain to you another beautiful rule. Now, because they have given you a compound like this, this is called a bicyclo compound. I'm again going to draw another kind of structure for you guys. For example, in exam, this kind of structure is given to you. This is again, bacha, these two positions in this kind of bicyclo compound. This is again a bicycle. These two positions are again, bacha, what? These two positions are again your bridgehead carbon. Bridgehead carbon. Okay? These two positions. Hence, these two positions can once again never attain a planar structure. Hence, they will never have a sp2 hybridized carbon over here. Okay? Only these things are written, and this is called, bacha, what is this rule called? This rule is called Bregg's rule. For example, in this bicyclo compound, these are the bridgehead compounds. Okay? And again, on these bridgehead compounds, a double bond is not possible. Why? Because what is the hybridization of carbon in a double bond? The carbon is sp2 hybridized, isn't it? Isn't it? So again, on these bridgehead carbons, there can never be a carbocation or a double bond. That meaning what? That there can never be a planar structure formation on the bridgehead carbons. These are called bicyclo compounds. For example, this is possible. This kind of double bond is possible. Here the double bond is present here. But here the double bond is present over here, or the double bond is present over here, are not possible because again these can never get a planar structure. Again, look at these bicyclo compounds, the planar. This is a stable structure. This is also a stable structure, right? But this is not possible once again. Okay? So this is called the Bregg's rule. Please look at these compound in your head very, very clearly. Very, very clearly. Okay? Now next are the elimination reactions that we're going to talk about. Elimination reaction means what? I again told you, elimination means what? Something is going to eliminate from your compound. You took an alkyl halide, right? In the alkyl halide, what happens? The carbon to which the halogen is attached is called the alpha carbon. Okay, and the carbon next to it, right next to it, is called the beta carbon. Okay, what happens? The halogen goes away from the alpha carbon, and from the beta position the hydrogen goes away. Can you see that if the halogen goes away from the below, the hydrogen is going away from the above, which means it is a kind of anti-elimination, isn't it? This is also a beta elimination, because from the beta position the hydrogen is going away. This is also a anti-elimination, because the elimination is happening from two opposite ends. Okay, understand this thing, and a alkene is formed, and this kind of compounds is formed. What is formed in the end of beta elimination? An alkene is formed. Okay, next is, for example, look at this structure. Now bacha, what am I using for the elimination? Again, look at this example. Here again, in the presence of what the elimination is happening, in the presence of a base. The first thing that you should argue, ma'am, this base also has a lone pair of electron. Ma'am, this base also has a negative charge. Can you see? So, ma'am, why are you eliminating in this case? But when this is similar as a nucleophile, isn't it? Isn't this structure similar as a nucleophile? Isn't this structure similar as a nucleophile? Hai bacha, let me know one thing. Because a nucleophile also has a lone pair of electron, a nucleophile also has a negative charge on it, isn't it? So bacha, now what is the thing that is making this base abstracting the proton and causing elimination? While we were calling it the nucleophile, we were using the substitution route, right? We were going through the substitution route through nucleophile, but in the elimination you're calling the same kind of negatively charged entity a base, and you are causing a elimination reaction. So bacha, I will let you know the difference between the two in just a while. Just keep in mind both of these things. Both of these things are same. Both have a negative charge on it. Both have a lone pair of electrons in it, but in one case elimination happens, in the other case substitution happens. When does it happen? We're going to discuss it right now. But first, look at this alcoholic KOH reagent. The reagent used here is alcoholic KOH. Remember this thing, whenever alcoholic KOH is given to you, then always and always elimination will happen and alkenes will be formed. But if instead of alcoholic, aqueous KOH is given to you, aqueous KOH means what? An aqueous KOH, substitution reaction will happen. Substitution reaction, which means what? In alcoholic KOH, can you see two kinds of alkene can be formed, which means this is the Br that has to be lost. This is the alpha position. Now this carbon has two beta position. This is also beta, this is also beta. So it has two possibility of losing the hydrogen. Either the hydrogen can go from this beta position or from this beta position, right? Two possibility of losing the hydrogen and two possibility of forming two kinds of double bond. One double bond is this, the other double bond is this. Which is the major product? The major product is decided by the rule called the Sedgwick rule. What is it called? Sedgwick rule. What does it mean? It means that the more substituted the double bond, more groups are attached to the double bond, more stable will be the double bond. For example, look at this group. Here to this double bond, this methyl group and this whole group is attached, correct? And to this double bond, only one methyl group is attached over here, right? So this is a least substituted alkene, hence it is least stable. This is the most stable alkene. More substituted, more groups are attached to the alkene, it will be more stable alkene. Okay? Again, the elimination depends on the kind of base you are using. Alcoholic KOH is a very, very strong base, hence it causes elimination reaction. Aqueous KOH is not that strong base, hence it causes a substitution. In presence, if instead of alcoholic, for example, if instead of alcoholic, I have the same CH3, CH2, CH2X. This was the product. Okay? This was the reactant, and instead of alcoholic, I used aqueous KOH. What will be the reaction now? The reaction will be simple. The X will go away and this will be substituted by CH3, CH2, CH2OH nucleophile. So the OH negative nucleophile will be added as a substituted product. So just look at the solvents given, look at the kind of reagents given, and substitution and elimination will take place accordingly. Okay? Now answer this question for me. Answer this question for me. Again, JEE Mains 2024 question. Very beautiful question once again. You've been given a bromopropane. A bromopropane is given to you, right? And you are reacting first of all with alcoholic KOH, right? Next is you are reacting the product form with HBr. Then you are reacting it with aqueous KOH. See, all of these things are given once again. I told you, with aqueous KOH, substitution happens. With alcoholic KOH, elimination happens. You need to know about these reagents. We're going to discuss about more, but first answer these questions. First answer this question. When Hoffman rule. Beta, Hoffman bromamide is a different thing that you're talking about. Hoffman bromamide degradation, we read it in amines chapter. Not here. Hoffman, there is no Hoffman rule that you're talking about. The answer, first answer I got is by Abhishek, propane 2-ol. Okay, let us see if Abhishek is right. Do I get any more answer, bacha? Do I get any more answer? Do I get any more answers? Okay, again, Jana has answered C. Okay, 2 people have given me the same answer. Okay, everybody has same answer. Raga Abhishek, Redox family. Wow, Redox family. What an interesting name. ठीक है. Chalo, what happens, bacha? First of all, elimination will happen. Elimination means what? The Br will go away from here and the H will go away from the beta position. So the A product, I'm guessing, should be CH3, CH, double bond, CH2. Isn't it? This is the A product. Now to the A, you are adding HBr. So how will I add HBr? That the Br, ma'am, will be add over here, right? And the H will be add over here. Isn't it? This will be the B product now. So I have made the B product over here. This is the B product now. Now what will happen to the C with aqueous KOH? Again, substitution product. So the Br will go away from here. Very good. Whoever has answered C. So the C product is CH3, CHOH and CH3 once again. Correct. The correct answer is C, propane 2-ol. Very, very good. Everybody understood this? Everybody understood this? Chalo. Next. Competition between substitution and elimination reaction. As I just told you, ki ma'am, the base that you're using in elimination, ma'am, that base looks similar to a nucleophile to me. How will I recognize when do I have to do the elimination reaction? When do I have to substitute it? How will I come to know? So, bacha, understand, there is always a competition happening in the molecule between the elimination and the substitution reaction. Always. So, how will you get to know ki when the elimination happens and when the substitution happens? So, number first thing that you should know, ki whenever the base is bulky base, bulky means it is a bigger base. Big base means tertiary butyl butoxide you are writing. You're taking some tertiary base or big base like RO minus. RO is you've attached a methyl group to the oxygen, right? So whenever the base is bulky, then it will always cause elimination reaction. Number first point, whenever the base is bulky, very, for example, CH3, CH3 and CH3, and here is the O minus. This is the tertiary butyl butoxide. Can you see how much bulky the base is? So whenever the base gets bulky, they will cause elimination reactions. Okay? Due to the steric reason. Why does it happen? Because it has become a very, very big nucleophile. So it cannot attack as a nucleophile now due to steric reason. It only shows that kind of reactions. Okay? Now the next thing, bacha, that you should know ki at high temperature. Number second, whenever temperature is given to you, so at high temperature, they will always show elimination reaction. Okay? So I've talked to you about the base given. If the base is a bulky base, if the base is a stronger base, then elimination reaction. Bulky base, stronger base, okay, alcoholic KOH. It is a very, very strong base, bulky base. Okay? And at high temperature also, if the temperature is increased in the reaction, For sure it will be elimination reaction. Okay, now let's talk about the alkyl halides. Alkyl halides. Let's talk about the alkyl halides. If the primary alkyl halide is given to you, what do you think should be the reaction? If the primary alkyl halide is given to you, they will always and always only and only show SN2 reaction. Remember this thing. There is no competition in primary. Primary, always the backside attack will happen and it will form a substituted product. Similarly, for the secondary alkyl halide, what will be the case? In secondary alkyl halide, there will be a competition between the SN2 or your elimination reaction. And what will sort out that competition? It will depend upon what kind of nucleophile. Again, if the nucleophile is bulky, then it will show elimination. If the nucleophile is not bulky and you are taking a secondary alkyl halide, then SN2 will take place. Similarly, with tertiary alkyl halide. Tertiary alkyl halide will either show SN1 reaction or they can also show with a elimination reaction. It again depends upon the base that you are using. If the base is bulky, elimination. If the base is not bulky, then SN1 reaction. Is this thing clear to everybody? And it also depends. SN1 bacha, this tertiary wala also depends on stability of carbocation. Because SN1 is happening, so it also depends upon the stability of carbocation. Number first thing, and also on the stability of alkene. So whichever is forming, whichever product is more stable will be formed in the majority of the cases. Is this thing clear? ठीक है? Competition I've discussed to you. Now let us do this question. PYQ, JEE Mains 2024. JEE Mains 2024. What do you think will be the answer to this? Statement 1. High concentration of strong nucleophilic reagent. What are we talking about? We're talking about strong nucleophilic reagent with secondary alkyl halides which do not have bulky substituents will follow SN2 mechanism. Do you think this is a true statement? They have given to you that there is high concentration of strong nucleophile. There's a strong nucleophile and there's a high concentration of it with secondary alkyl halides. The alkyl halide bacha is secondary, which do not have bulky substituents will follow SN2 mechanism. Tell me the answer to this. Tell me, is this a true statement or is this a false statement? Just tell me this much. I'm only talking about statement number 1. What do you think? Is this a true statement or is this a false statement? Beta, Hoffman rule. What Hoffman? There's no Hoffman rule. There is Hoffman bromamide degradation that we study in the amides chapter. What are you trying to ask me? False statement. Tanishka has told me false. But this is a true statement. This is a true statement. B.S. Patel's answer true. Game over. I mean true. B.S. Patel 2. Both statement true. Correct. This is a true statement. But why? What was SN2? SN2 was a bimolecular reaction. Remember, its rate depended both on the concentration of the nucleophile as well as the concentration of the alkyl halide, isn't it? And they have given to you that nucleophile is strong, and I told you SN2 is favored by strong nucleophiles. Strong nucleophile and there is a high concentration of it, and SN2 depends upon the high concentration. Secondary alkyl halide, secondary is not that substituted like the tertiary. Hence, this is a true statement. It will follow the SN2 mechanism. This is true. Okay? This is true. Next is a secondary alkyl halide when treated with a large excess of ethanol follows SN1 mechanism. Who can answer this question? So you have in the statement it is given that you have a secondary alkyl halide. Okay? When treated with a large excess of ethanol, which is your nucleophile, will follow SN1. Is this a true statement? Is this a true statement? Is this a true statement? Both are true. Game over Tamil is answering both are true. Correct, true. This is a true statement once again. ठीक है. Should I move forward? चले आगे आगे चलते हैं रिएक्शन विद मेटल्स में. हम आप बात करने वाले हैं रिएक्शन विद मेटल्स के बारे में. बेटा that is Sedzeff rule, not Hoffman rule. Redox family. Least substituted product is the Sedzeff rule or the Markovnikov rule. Hoffman rule is what? Reaction with metals. ठीक है? Reaction with metals is what? You take a alkyl halide and you're trying to react it with a metal or a dry ether. ठीक है? Now what happens? This is a very, very popular reaction which is called the Grignard reagent reaction. What it is called? It is called the Grignard reagent, isn't it? This is called the Grignard reagent that we are forming. What is happening? What is happening? The Mg gets attached over here. The Mg gets a delta positive charge. Br gets a delta negative charge. And CH2 also get a delta negative charge. Why? Because Mg is a metal. Metal will always be more electropositive in nature. Can you see this kind of product that is formed is called a Grignard reagent product. I can also write it as like this, RMGX. ठीक है, X will have a negative charge on it, plus magnesium will have a positive charge on it because it is a metal, and because the carbon is attached to the more electropositive metal, hence the carbon will have a delta negative charge on it. Remember this thing. What kind of bond is RMG bond? The RMG bond, bacha, is a covalent bond. Can you see this covalent bond also has polarity in it? Magnesium is positive, carbon is negative. Hence, this bond is bacha kind of a polar covalent bond. RMG bond is a covalent bond. These kinds of compounds are also called organometallic compound. What are they called, bacha? These are called organometallic compounds. Right? These are also called organometallic compounds. These are also called polar covalent compounds. Correct? The next thing is, what kind of bond is between Mg and X? What kind of bond is between Mg and X? So Mg and X, bacha, is a ionic polar bond. Isn't it? Ionic polar bond. This bond is ionic while the RMG bond is covalent. ठीक है? This is the thing that you must know about the Grignard reagent structure. ठीक है? Now, बच्चा, the Grignard reagent that we have formed functions as a very, very good substance to create more products out of it. For example, I took a Grignard reagent. Grignard reagent is a very good proton abstractor. It abstracts proton from any and everything. For example, from H2O, it can abstract a proton. For example, from alcohol, it can abstract a proton. For example, from ammonia, it can abstract a proton. From any amine, it can abstract a proton. So from all these things, it can abstract a proton, and finally it will form, in all of these cases, it will actually form a normal alkane product. After abstracting the proton, it will form a normal alkane out of it, and the MgX will go away in the form of MgOH and X molecule. This thing you should know. Everybody is understanding this thing? NH3 or even NH2. So in all these cases, alkene will be the product. So can you see, bacha, RMGX is a very, very reactive molecule. What kind of molecule is this? It is a very, very reactive molecule. Reactive means what? Reactive means it is very reactive, so that even in the presence of some moisture, it can react and form an alkane. Hence, bacha, what do? We conduct these reactions in the presence of dry ether. Remember this thing. We never conduct these reactions in water or any solvent. Why? Because it's a very reactive towards water. It abstracts the proton out of it. So we always do these reactions in dry ether, because this can even react with the moisture in the atmosphere. Okay? Very, very reactive molecules. Now, next thing that you should know is the Woods reaction. Reaction with metals that we're going to study. The next is the Woods reaction. Woods reaction, bacha, what happens in Woods reaction? We took a alkyl halide. I just taught you in the last lecture. The alkyl halides, it gets treated with the sodium metal. So whenever any alkyl halide plus sodium is given, it means that's a Woods reaction that you have to perform. In Woods reaction, what happens? The alkyl halide reacts with itself. It will react with itself, and these Br molecules will go away, and it will form a bond with another, which means it is forming a dimer kind of compound. It loses the halogen and forms a dimer with itself, just like this. For example, we started with the methane and we got a ethane molecule over here. So in Wood's reaction, what is happening? You are getting symmetrical products. What kind of symmetrical products you are getting? Number first point. Number second, also you are getting even number of carbon products. You're getting symmetrical products and also even number of carbon products. ठीक है? Grignard यहाँ acid base कर रहा है ना? Grignard, let us look at Grignard once again. So Grignard has a positive charge on it and it takes away the H plus out of it. The H plus is taken. Yeah, you can actually say any positive negative reaction that happens is actually an acid base reaction. ठीक है? ठीक है? ठीक है? Next, even number of carbons. Next is previous year question. Who can answer this? So I explained to you what happens with the Wood's reaction, right? And Wood's reaction, some other properties that you should know, that only even number of carbon products are formed. For example, 2, 4, 6, 8, right? 3 number of carbon products are never formed. And if you try to react two different kinds of, for example, if I'm trying to react CH3Br plus Na and I'm trying to react it with Br and C2H5. I'm trying to react it with 2 different kinds of alkyl halides. So this will go away, right? And these will join together. But in this case, we actually get a mixture of products. For example, this CH3Br will react with itself and form a ethane molecule, CH3 molecule, correct? And this ethyl bromide will react with itself and form a butane molecule, which is C2H5 and C2H5. The next product that is possible is that these two react with itself and form a propane product, CH3 and C2H5. So in this case, if we take 2 different kinds of alkyl halides and you are even able to get a odd number of products, but can you see that you actually get mixture of products in that case? So this reaction is again not feasible because it is very difficult to separate these products now, because you got 3 kinds of products in this case. Now let's do this JEE Mains 2023 question. Compound A, this is the compound A, bacha, you have given, undergoes following sequence of reaction to give compound B. Some compound B is formed. The correct structure and chirality of compound B, where ET is C2H5, okay. Compound A is, bataiye, what can be the compound B? First of all, can you see how to solve this reaction? You've been given magnesium in ether, right? This is what? This is a ether, diethyl ether, right? I told you in diethyl ether what happens? Grignard reagent is made. So the first step will be the formation of Grignard reagent like this, MgBr. Now you are reacting this Grignard reagent with D2O. D2O is what? Is again an isotope of water, right? D is what? Deuterium. So what happens in this case? I told you that MgBr, Grignard reagent, is a very good proton abstractor. It abstracts the proton from here, which is D+. And hence, the final product form will be just like this. Here, the D will attach. Now, let me know, I have told you the product, what will form. Is this a chiral product or is this not a chiral product? Is this chiral molecule or is this not a chiral molecule? Who can answer this question for me? Yes, RD, not RH, but RD will be formed. 2,3-dimethyl butane. Maths class is scheduled at 6 p.m. bacha. Then I will have to leave the class then. If it is scheduled at 6 p.m., let me check. Let me check. But still, let me know, is this molecule chiral or not chiral? I'm checking till then. If the class is scheduled, then probably I will not take the class. Then I will have to end it. Let me check with ma'am. Let me know if this is chiral or not. Once. Hello ma'am, will you be taking the class? Okay, okay. 1 second. If it's possible. ठीक है, फिर मैं 7 o'clock तक दे ठीक. Okay, bacha, they will be of chemistry, maths class. Sorry. Okay, I've received so many answers. Game over Tamil is saying it's chiral. Cheku is saying not chiral, and then everybody and other people are saying it's chiral. Bacha, this is a chiral molecule. Chiral means what? The carbon should be sp3 hybridized. Can you see that this carbon is actually sp3 hybridized? This is a carbon. Here will be the hydrogen. Here is the again another structure is given to you, right? Can you see to this carbon 3 different kinds of groups are attached? This first of all is a sp3 hybridized carbon. To this carbon 4 different groups are attached. Hence this is for sure a chiral molecule. Hence this is a chiral molecule and this will be the product. ठीक है? Everybody understood? Everybody understood this? Let's move. This is a chiral molecule, bacha. It is a chiral. It is a chiral. Who is saying this is not chiral? This is a chiral molecule. Ma'am, can you explain chiral and achiral once again? Okay, I will explain to you what is chiral and achiral. See, for chirality, this is a carbon molecule. To this molecule, A, B, C and D. So first and foremost criteria for chirality. Criteria for chirality is bacha, the carbon should be sp3 hybridized. ठीक है? No sp2, no sp hybridized carbon will ever be chiral. sp3 hybridized only can be chiral. Second criteria is that all the 4 groups attached to the carbon, all the 4 groups should be different. Totally different group should be attached. Only and only then your carbon will be a chiral carbon. Okay, understood? 2 points are there for the chirality. Third, if you want to check the chirality of the entire molecule. So in the molecule when it comes, then the entire molecule should have no symmetry in it. Another point adds, for the entire molecule there should be no symmetry. Okay? If there is any symmetry present, then that molecule will not be a chiral molecule. So there are 3 points to understand. First, the carbon should be sp3 hybridized. Second, to the carbon, all the 4 groups attached should be different. Right? Third is there should be no symmetry present in the compound. ठीक है? Chalo. Let's move on to the next question. Next example. Sorry about that. Yes, who can answer this question for me? This is again a JEE Mains 2023 question. In the following reaction, X is. So you have taken a normal hexane molecule and you're trying to react it with anhydrous AlCl3 and HCl molecule and heating it. Then what will be the reaction? This is a different kind of reaction. I want to give you this as homework. Okay, I need you to actually sit and reflect upon what is this question asking, because we have discussed a lot of similar things related to it. What is anhydrous AlCl3? Ma'am, is it a kind of acid? Is it a kind of catalyst? And in the presence of HCl, and now I'm heating it. What can be the product form? What can be the product form? Okay, let me tell you, this is a different kind of question. Okay, let me tell you the answer. But in this, what happens? This is a new kind of reagent. This reagent I don't think is given in your NCERT. If it is given, it might be given in the hydrocarbons chapter. I do not recall it. It might be present in the hydrocarbons chapter. But here what happens with the AlCl3? Isomerization happens. We studied it in the hydrocarbons chapter, right? In the hydrocarbons, whenever you use aluminium trichlorides, isomerization happens. Hence, in this case also again, isomerized product will be formed. There is no role of chlorine in here. Okay? So the only product formed will be the isomerized product. No bacha. The actual answer to it is actually the third option. Can you see? A normal hexane is given to you, right? And the normal hexane gets converted into a isomerized. This is 2-methyl pentane molecule. So what is happening? Isomerization happens. Isomerization. Okay, so again, this reagent can be from a hydrocarbons chapter given in some other format, but we know whenever aluminum trichloride is there, isomerization reactions happen. That is it. So the right answer is third. Okay, right answer is third. Why have I included this here? So that you get to know more and more different kinds of reagent asked in your exams. Okay, now next question. Compound from the following that will not produce precipitate on reaction with AgNO3. Which will not produce a precipitate on reaction with AgNO3? Who can answer this question for me? Who can answer this question for me? Not produce a precipitate with AgNO3, which means what? Which will not give Br easily, right? Which of these will not give the Br easily? Very easy reaction. Very, very easy. Very, very easy. We have to take out the Br minus from here. If the Br goes away, the positive charge remains over here. This is a vinylic carbocation, not stable. Very easy. Again, if the Br goes over here, the positive charge comes over here. This is a benzylic carbocation. This will definitely form precipitate with AgNO3 and will form AgBr, isn't it? This will form AgBr. This again, if this is lost, the carbocation formed is a allylic carbocation, or it is in resonance with the ring, right? So this will also form the precipitate with AgNO3. Again, this, if the Br minus goes away, the carbocation formed is again a allylic carbocation. It will also give the precipitate. But this will not give any precipitate, hence the right answer is actually 1. Because the carbocation formed here is a vinylic carbocation, which is very, very unstable. Can you see? Same concept is repeated in so many different kinds of things. So you just have to keep your brain open and know how to approach those questions, isn't it? Carbocation, yes, bacha, you are absolutely correct, DS Patel. Carbocation mechanism will be followed, है ना? Because AgBr means what? The Ag will be plus and Br will be minus. So we know कि ma'am here, from here the Br minus will go away. Only and only then AgBr will act as a precipitate. है ना? चलो, next. Next is chemical reactions of haloarenes. We have completed haloalkanes, everything about haloalkanes. Now we are going to do haloarenes chapter. Haloarenes topic. Number first, do haloarenes show nucleophilic substitution reaction? Nucleophilic substitution means what? Means that this chlorine will go away and will be instead substituted by some other group. Will that happen? That never happens. Always remember, these never show nucleophilic substitution reaction. The chlorine never goes away. Why? Because look at this resonating structure. What is happening with this benzene ring? The chlorine has so many of the unpaired electrons with it, isn't it? The chlorine has so many unpaired electrons, and all those unpaired electrons actually go in resonance with the entire ring. Hence, this CCl bond actually gains a double bond character, right? This CCl bond actually gains a double bond character, है ना? Everybody can see that, and it is very difficult to break a double bond. Hence, this C double bond, Cl bond do not break. This Cl bond do not break. Hence, it does not show substitution reaction. This is the reason number 1. Why haloarenes do not show nucleophilic substitution. For example, when I was talking about alkyl halides, what I was doing, this was the alkyl halide. Okay, I was substituting it with some nucleophile. What I was doing, I was breaking the C carbon and halogen bond. Can I break the carbon halogen bond over here? No, I can only break the carbon halogen bond in the case of alkyl halides, है ना? Because this is easier to break, but aryl halides, due to the double bond character, we cannot break this bond, hence they do not show nucleophilic substitution reaction. Reason number 1. Reason number 2 for why they do not show nucleophilic substitution reactions. Number 1, because here the carbon to which the halogen is attached is sp to hybridize. While in the alkyl halide, the carbon to which the halogen is attached is actually sp3 hybridized. And as you know, ki sp2 hybridized is more electronegative, isn't it? The sp2 hybridized is actually a more electronegative carbon. What is the purpose of electronegative carbon? Ki I am more electronegative, hence I will attract more electrons to myself. Hence this bond, this and this halogen is electronegative, right? So it means what? That this carbon will hold the electrons more closely towards itself. Hence it will not easily let the bond break, because now the electrons are more attached to it due to the more electronegative character, right? So therefore, due to this sp2 hybridization, again they do not show the nucleophilic substitution reaction. Okay. Number third reason that they do not show the nucleophilic substitution reaction, two reasons I've told you. Number third is that the phenyl carbocation, for example, this was the haloarine, right? This is the haloarine. Now, if I want to take away this chlorine, what can be the result? The result can be the formation of a phenyl carbocation. And this phenyl carbocation, bacha, is very, very unstable carbocation. Because it is so unstable, it is never formed. Hence, they do not show nucleophilic substitution reaction. Number fourth reason. This is your haloarine, isn't it? This is the structure of haloarine. Now you want to attack some nucleophile to it. Okay? Now look at this structure. What does this haloarine have? It has a benzene ring attached to it. Benzene ring is has so many pi bonds in it, right? All these pi bonds are electron rich bonds, isn't it? So benzene ring, bacha, is very, very electron rich molecule. And to this electron rich molecule, you are attacking another electron. This is electron. This is what? Negative species. I am already electron rich and you're attacking more electron positive species to me, which means I will cause more repulsion because I'm already so electron rich. Hence, attack of any nucleophile to the haloarine will cause so much of repulsion. So due to these four reasons, haloarenes do not show substitution reaction. Substitution means what? The chlorine goes away and is replaced by some other nucleophile. So they do not show the substitution reaction due to these four reasons that are discussed over here. Okay? The next point is, but sometimes they do show substitution in rare cases. What are those cases? Number one case, for example, to the haloarine, you are given very drastic condition. Can you see that the reagent uses NaOH? NaOH means what? It will give away the nucleophile OH negative, right? Now you are doing this reaction at 623 Kelvin at 300 atmospheric pressure and in the presence of some acid. Right? So you have given drastic condition. In drastic conditions, it can happen that this chlorine will go away and is replaced by the OH negative. Substitution can happen in drastic condition. Number second, even sometimes substitution reactions can happen when, bacha, what have you attached? I told you that this benzene ring is actually electron rich molecule, isn't it? That's what I told you. Electron rich. So if I attack any group which is the electron withdrawing group, for example, NO2, right? If I attach any group which is electron withdrawing group, then what am I doing to it? What am I doing to it, bacha? And I have also given it 443 Kelvin. I have attached one NO2 group at the para position. Now, because it is electron withdrawing, it is reducing the electron density in the ring. Hence, the nucleophile can attack over here, right? So it gets replaced by the nucleophile. Next, again, what happens? You have attached two NO2 groups at the ortho and para position. In this case, again, can you see I've reduced the temperature now. Again, the chlorine gets replaced by the OH because again, two NO2, two electron withdrawing groups are attached. Hence, this OH negative can act as a good nucleophile. Similarly, what happens now? You have replaced all the ortho and the para positions with the NO2, which is the electron withdrawing group. So you are decreasing the electron density inside the ring. You are decreasing the electron density. Hence, the nucleophile can attack. So only with the presence of some warm water. Warm water again acts as a nucleophile. So again this chlorine atom gets replaced by OH when all the ortho and para positions are replaced by the nitro. So one thing that you have to notice is when the electron withdrawing groups are attached only to the ortho and the para position, only and only then the rate of the reaction is affected. If the NO2 group was at meta position now, then there will be no substitution happening, because at meta position the electron withdrawing effect is not at all that effective. Okay? Why? Now let us look at their resonance structure. For example, where the NO2 is at the para position. So what is happening when the NO2 is a para position? For example, the OH negative attacks over here. So after the OH negative attacks, the negative charge moves inside the ring due to resonance, right? So can you see that the negative charge actually goes to the ortho and the para position? That is it. So when it goes to the para position, and the para position you have already attached a electron withdrawing group. So it is taking away the electron from the ring towards itself. Hence it is stabilizing. Hence it is making a stabilizing the structure, right? So at the para position, the negative charge gets stabilized, right? Similarly, let's talk about the ortho nitrochlorine. So in this ortho nitro chlorobenzene, what is happening? The ortho isomer, again, let's attack the OH negative. Hence, again, you can see that the negative charge goes to the ortho position, right? So when the negative charge goes to the ortho position, it is able to attract electron towards itself, the NO2 group, and it is able to stabilize the benzene ring. But if you attach the NO2 group, which is the electron withdrawing group, to the meta position, है ना? Now, bacha, again this OH negative attacks over here at the position of Cl, right? And then can you see when I make the resonating structures now, the negative charge do not come at the meta position at all, right? The negative charge only moves at the ortho and para. Hence, this NO2 group at the meta position is not able to stabilize the negative charge. Correct? It is not able. Here, the negative charge only moves at the ortho and para. Hence, we have to attach the electron withdrawing groups at the ortho and para position to make the ring reactive. At the meta, there will be no effect on the reactivity and there will be no reaction happening. Okay? But in drastic condition, what you are doing, you are increasing the temperature and pressure so much more that the bond will definitely break, right? You have just made the conditions very drastic. In drastic conditions, anything is possible, right? But to achieve those conditions, to make such high temperatures, such high pressures, you need so much of equipments, which is not commercially possible and feasible, right? So we prefer to not do those reactions. Okay? Beta, maths class will be at 7. Will be at 7 now. Now answer this question for me. The compound which will have the lowest rate towards the nucleophilic aromatic substitution on treatment with OH. Are you bored with chemistry or asking about maths class with me? Are you bored with chemistry already? I think I've told you many interesting concepts. See, I always try to just dig into the PYQs and just dig out those kinds of reactions which nobody talks about. But you have to know the approaches to them. Do not be bored of this, bacha. ठीक है? Let me know the answer to this question. Which will have the lowest rate towards nucleophilic aromatic substitution on reaction with OH minus? Look at the JEE Main 2023 question exactly. NCERT question, है ना? That's why I keep telling you कि NCERT is very important. Whether you're preparing for NEET, whether you're preparing for JEE, same questions are asked. Who can answer me this question? Who can answer me this question? Thank you, B.S. Patel. Okay, Sumanti Satish has answered. Lowest rate towards, very good, the meta. The meta will have the lowest rate. Correct response. Correct. I've received so many response. ठीक है. Very good. Next is electrophilic. So what actually happens? I told you कि nucleophilic substitution does not happen. And when does it happen? We also discussed that a drastic condition or whenever some electron withdrawing groups are attached, it may happen nucleophilic substitution. But what reactions do haloarenes usually show then? They usually show electrophilic substitution reaction. So what is happening, bacha? What is electrophilic? Can you see the benzene ring is, again I am telling you, benzene ring is electron rich ring, है ना? Benzene ring is electron rich ring, correct? So electron rich means what? Anything which is positive, it is called a electrophile. Anything which has a positive charge is called a electrophile. Electron loving will be something positive. So it will always show electrophilic substitution reaction. So some positive species can easily substitute this benzene ring. And why does it show electrophilic substitution reaction? Again, look at the X is what? Any halogen attached. Halogens have what, bacha? Halogens has lone pair of electrons in them. And these halogens do what, bacha? These halogens show two kinds of effect. One is the minus I effect and the other is the plus R effect. Plus R is because of their presence of lone pairs. What do they show? They show resonance with the benzene ring. Can you see that with the benzene ring they're showing resonance and increasing the electron density on the ring. Can you see at the ortho and the para position they're actually increasing the electron density on the ring. One second, bacha. This is booked
for me.
You can go check. Oh, this is booked for us. ठीक है, ortho and para directing, this is how we do. Now, due to the resonating structure, bacha, what is happening? It is increasing the electron density on the ring. Hence, it is becoming negatively charged on the ortho and para position. So, can you see? Because the negative charge is coming at the ortho and para position. Hence, these are ortho and para directing groups. Isn't it? These are ortho and para directing groups. Even though X is X shows minus I. Minus I is what? Minus inductive effect which means what? It is an electron withdrawing group. But that is a very limiting nature of it. Most of the effect is shown by the plus R effect because plus R is the dominating effect. Hence it shows this kind of effect. ठीक है? These are ortho para directing groups. Next is what kind of electrophilic substitution they show? They show kinds of halogenation reaction. This is your aryl benzene, right, with the chlorine and some kind of catalyst. For example, anhydrous FeCl3 or even anhydrous AlCl3 you can use. What are you doing? You are trying to do halogenation. So halogenation occurs at the ortho and the para position. And always remember the para product is the major product because it is the least hindered product. Both of the two substituents are opposite to each other. Hence it is the least hindered product. Next is, bacha, the nitration. The nitration that we talk about, right? Nitration, what are the reagent for nitration? It is HNO3 and concentrated H2SO4. Okay, we took the aryl benzene. I'm trying to react it with HNO3 and H2SO4. And what did I get? I got these molecules. Okay, I got a nitrated molecule at the ortho and the para position. Again, the last kind is not the last kind, second last kind, sulfonation. Sulfonation happens in the presence of concentrated H2SO4. The electrophile here is SO3H+. Remember this thing. Okay, what is the electrophile here? The electrophile in nitration is NO2+. Remember the electrophiles. NO2+. Correct. Here it is SO3H+. Okay. Next is the Friedel-Crafts reaction. Friedel-Crafts is a very important category of reactions. You take a aryl benzene and you react that aryl benzene with methyl chloride in presence of anhydrous AlCl3. Okay. Now, bacha, what happens? What happens here? Again, the Cl goes away from here, right? And the CH3 plus actually attacks here. Okay? This is the final product that is formed. What is the mechanism of this reaction? We're not going to talk about it here. Okay? And if you want to know the mechanism, I can also tell you the mechanism. Let me just do. For example, this is the aryl benzene. This was the aryl benzene that I drew, and then here it was the CH3Cl, and I was trying to react it, for example, with AlCl3 molecule, which is a very, very good Lewis acid. Why? Because it is a electron deficient species. AlCl3, bacha, is a very, very good Lewis acid because it has only 6 electrons in them. So what will happen? This Cl minus will get attached to this AlCl3 and it will form a AlCl4 minus kind of structure. ठीक है? What? Okay, sorry students, sorry for the lag. Now what we are doing, so we just made it like this. Okay, AlCl4 minus is happening, and then what it will leave behind to us, it will leave behind some kind of CH3 plus species. So here a carbocation species is actually what? Your electrophile. So this carbocation will now attack either the ortho position or the para position, right? So your final product, as I discussed to you, is actually this kind of product. Similarly, this is called, bacha, this first reaction is called Friedel-Crafts alkylation. What is this called? This is called Friedel-Crafts alkylation. Similarly, there is another set of reaction which is called Friedel-Crafts acetylation. ठीक है? In Friedel-Crafts acetylation, what happens? We take again a chlorobenzene and then we're trying to react it with CH3COCl in the presence of anhydrous FeCl3, and again the Cl goes away from here, and from this CO part the actually attacks to either the ortho or the para position, and two kinds of products are formed, and obviously the para product is actually the major product formed. ठीक है? And the last reactions are the reaction with the metals. Again, just like your haloalkanes, it also shows a variation of the Woods reaction. What is the variation? Here the reaction is called the Woods-Fittig reaction, where one of the reactant is a aryl halide, the other reactant is a alkyl halide, and the presence of sodium, you actually make a dimer. Out of this X goes away from here, this X goes away from here, and the R attaches here and forms a dimer just like this. It is called Woods-Fittig reaction. You need to remember the names because these exact direct naming and the reactions are asked in your JEE exams. I'm again and again telling you name reactions are very important. Next is a Fittig reaction. Fittig is when two aryl halides, right? When two aryl halides join together to form a dimer just like this, like a diphenyl product, it is called a Fittig reaction, right? And now we are going to do some of the PYQs. I guess I need to end this session right now. Okay? And some of the PYQs you can attempt. It will be there in your PDF that will be there. Okay? You can try and attempt like 4 or 5 PYQs attached with this topic. Right now, I do not have any more bandwidth to continue because this studio is used by so many people to record their sessions. I need to give it to them. Okay, thank you, Game Over Tamil, but probably Namrita ma'am will take the class in 30 minutes. I will let her know. Thank you for attending this session. And if you have any doubts, any questions, any suggestions, any feedback for me, you can let me know in the comment section. And I will see you again in the next video. Bye-bye. And you have any, right now I'm preparing for JEE, na? I need to talk to you about one more thing. If you're preparing for JEE, where in the organic chemistry especially, what are the things that you're not able to grasp? Where you are not able to solve the questions? Where is the thing that you think, ma'am, whenever this kind of thing comes, I'm always stuck. I'm always stuck. So let me know in the comment section below so that we can, before your JEE exam, we can come out with a way to help you in those sections. Correct? Thank you. Thank you, Tanishka. Bye-bye so much. Thank you so much, class. My name is Nandini, signing off. Bye-bye.